All right, welcome everyone. So we still have about 12 minutes left before the official start of the session. So if there are any questions in the meanwhile, please post them in Discord. All right, so you have about 5 more minutes until the official start of the session. So in case there are any questions already, feel free to ask them in Discord. We'll still be waiting for about 4 to 3 minutes for everyone to join before we start. But yeah, if anyone has any questions, feel free to ask them already, right? All right, I see some more people joining already. So let's wait just a couple more minutes, a minute or two. If there are any questions already, feel free to ask them in Discord. Maybe one thing to address a question that was asked last time by John. He asked if it would be possible for a user or for a user administrator to reset the password of another user which had, for instance, a global administrator role assigned to him, but which had that eligible, right? So not an active role assignment for that. Because if that would have been possible, that would have allowed some privilege escalation opportunity, right? But I looked into that, and it seems like Microsoft actually took that into consideration. So that's great to to see that they, for once, probably someone looked into this well to not allow any privilege escalation pods there. Any other questions before we start the session? All right. In that case, let's actually start the session officially now. So, welcome everyone to the fourth and sadly already final session of the Attacking and Defending Azure Cloud Advanced Azure Advanced Edition. Right. So, Attacking and Defending Azure Cloud Advanced Edition of the October 2024 batch. Right. So last time we completely completed learning objective or kill chain 3, right? So we ended by looking at enter ID Kerberos, right? Which provide us access to a file share that's provided us the final flag, right, for kill chain 3. Meaning that today we will start with the final kill chain of this lab, kill chain 4, right? So as we said in the beginning, every kill chain is completely separate from all the other kill chains. So you will see that we will once again need to start with some initial access technique, right? So let's look into that. All right, so this time we are going to look into illicit consent phishing a little bit again, because in the basic class we already also looked at consent phishing. However, we're gonna execute the phishing attack in a slightly different way. Right, you will see there will be some variances in that. We will use a completely different tool, but we will also be doing something else completely, because in the basic class we fished for low impact permissions, right? Which do not require administrator consent, right? So consent and permissions. If an application wants to access data in your Enter ID tenant, right, that could be something very basic like low impact permissions to be able to sign you in, right, to be able to see your profile, see your email address, things like that. They're all called low impact permissions. For an application to be able to access that, the user would first need to grant consent to the application to allow it to access that information on behalf of it, right? So this is delegated permissions that the application would be able to request after consent would be given by the user, right? So by default, this is turned on, right? Everyone can grant consent by default. We will see that later on, but only for low impact permissions, right? All other permissions that are not classified as low impact would require administrative consent, right? There are a couple of administrative roles that can allow tenant-wide administrative consent, right? Which we will see a little bit later on. Right? So these roles would be able to grant consent to the application for higher impact permissions as well. Right. So what do we mean with low impact permissions? Right. So all permissions that do not need admin consent will be classified as low impact. Right. So for example, permissions required for basic sign-in, as I said. So OpenID, profile, email, user.read, and offline access are the main low impact permissions, right? However, there is even one interesting one, as highlighted here below. You have the user.readbasic.all permission, which is the only other low impact permission that a user, any low privilege user, would be able to consent to, right? And this permission, as the permission itself indicates, allows an application to read basic information from all users in a tenant, right? So if a unknowing user would consent this permission to an application, that application would then be able to, on behalf of that user, read the basic information of all other users in the tenant, including their display name and their email address, for example, right? So it could be very useful if you want to get some insights into which other accounts exist in the organization, right? With that information, you could, for instance, do some more targeted attacks later on, right? If you have a big list of email addresses, you could always try to do a password spraying attack, for example, right? Which might not always work anymore. If multi-factor authentication is in place, right? But you might still be able to use that for something else, right? So question is, the application consent will only be delegated, so not application permissions, right? So it's, yeah, indeed, it will be delegated permissions, meaning that if the user grants that consent, the application will be able to list all the users in the organization, but only if a user is signed in, right? So they will be able to access that with the privileges or on behalf of the user that's signed in. It will not be able to access that on its own with its own credentials, right? It will not be able to access that information if no one else is signed in to the application, right? Because that would always require admin consent to allow an application to sign in on behalf of itself without any other account, right? If that answers your question. Great. All right. So that means that most fin permissions need administrative consent. Luckily, of course, for the organizations that would need to be targeted by these kind of attacks, right? But for us, that's a little bit sad, right? However, you can still try to fish for these higher privileges, right? If you target a user that is able to grant tenant-wide consent, so consent on behalf of the complete organization, so that would not be delegated anymore. But even these users that would be able to grant admin consent would also be able to grant delegated permissions to an application, which would require high, which would be classified as high impact, right? So not low impact permissions only. So which roles are this? by default, obviously, the global administrator and the privileged role administrator would be able to provide tenant-wide admin consent for any permission for any API, right? So these two, if you would compromise one of these, this could be something useful that you could do for persistence afterwards, right? However, even other roles such as application administrator and cloud application administrator would be able to grant tenant-wide consent for everything except for Graph API permissions, right? Because if that would have been the case, that would have allowed these two roles to perform some privilege escalation, right? So that's why it's restricted to the global administrators and the privileged role administrators, right? Because the Graph API would allow an application to assign other roles, right? And then it would allow you to do privilege escalation, right? You could also create a custom role, and then you could also assign that role to a user to allow them to grant tenant-wide admin consent. But by default, these are the four roles you would want to target. So the way this is restricted depends on the user consent setting. So there are 3 ways you can configure that. So let me actually show you that in the portal. So probably be a little bit easier to show that over there. And so I'm already there, but let me show you where you can find that actually. So if you go to Enter ID, Enterprise Applications, and then under Security, you have Consent and Permissions. So this is where the user consent settings are configured. We zoom in a little bit. And you will see that it is currently for the all corporation tenant configured as allow user consent for apps. So this is also the default setting. It's not the recommended setting, as you will see. Over here it says recommended, even though Microsoft doesn't put it on the recommended setting by default. So by default, it will be this. Right. So the most restrictive permission would be to set it to do not allow user consent at all, right? So that would mean that if a user would need to sign into any application that would request access to its data, it would not be allowed to do that. It would always require an administrator to approve that, right? The recommended setting is to allow users to consent for apps from verified publishers, right? So it's a little bit harder for an attacker to become a verified publisher, right? Because then you need to get approval from Microsoft first when you publish your application, right? And also only for selected permissions. So you will see if you do this, users will be able to consent for low impact permissions from verified publishers or from applications within its own organization, right? And the most lax setting, which is the default one, is to allow users to be able to consent for all applications. So also applications that are not from verified publishers and not from within your organization, right? Note that if you are able to gain access to an account in an organization, and even if it's set to the recommended setting, by default, low privileged users are also able to create their own app registrations, right? Meaning that even if it's set to recommended, let's say you already have a user that you have compromised, you would be able to create an application within the target organization and then use that application to perform consent phishing internally in the target organization, right? So you could do some internal spear phishing, for example. And then you would even be able to do that if it's set to the recommended settings, right? Which most organizations will be having it set to, right? But by default, all of organizations will also have it set on allow user consent for all applications, right? Because that is a default setting. What else do we have? You have the admin consent settings. So here you can basically define if a user is unable to provide consent to an application, what should be done, right? So if you set this to yes, then a user can request administrator consent for that application, right? So you will probably have noticed this already when you try to access an application, for example, which you are not able to provide consent to. Then it's if your organization has this set up, then you can instantly request administrator approval to still provide that consent, right? And then you can also define which users or groups will be able to provide that that admin consent, right? The permissions classification. So here you can see the default low permissions, low risk permissions over here. So these are all of these, and also the user.readbasic.all, right? You can also, it is possible for an organization to add their other permissions and classify them as low risk. So that would allow users to also request these other or consent to these other permissions on other type of applications, right? Without requiring administrative consent, right? So you can see over here, if you go to a Microsoft graph, for example, you would see all the permissions that would be required, right? You can also see which of them would require admin consent. But you will see, if I go for email, for example, or mail, you will see that it sometimes will say, for instance, mail.read will not require admin consent, which is strange, right? Because it would require admin consent, but only if it's from an application from outside of your organization, right? So if you would be able to create an application inside of the target organization, you would be able to, by default, request some more privileged permissions, right? So if you would be able to use this for internal spear phishing, you might be able to use that to gain access to a mailbox of a user, right? And even send emails as them, right? These are all delegated permissions, right? All the application permissions, as you can see over here, would always require admin consent, of course. All right. Something else that I wanted to show you, the tenant. If we go to the user settings over here, so I said by default users will be able to create applications in an organization. That's because of this setting. So by default, this is set to yes. Right? So if a user is compromised and you have this setting set to yes, an attacker would be able to create their own application and use that for consent phishing within your own organization, right? So that is why you should recommend organizations to disable that, because by default, normal, regular users do not need to create their own app registrations, right? There is no real reason for a low privilege user to do that in most organizations, right? Depends on your policy, of course. But as you can see over here, it is also set to the default setting, which would allow you to do this. The question is, in the permissions classification blade, what does the effect of the medium permissions actually do? So let me actually show you that to show you what this actually refers to. So you probably mean this one. You can also classify permissions as medium or high risk, right? This is in preview. I don't think it will do anything by default. However, you can create custom consent policies, and then you would be able to do something with that, right? So this is in preview. I have never actually seen organizations using this myself, but I think by default, if you don't have a custom consent policy, it will not do that much, other than maybe you could override the default low impact permissions. I think, not really sure, but yeah, I don't think there is any reason to do that right now. Yeah, indeed. It's not documented that well. Classic Microsoft, right? Okay. So let's look into how we will actually perform this consent phishing attack. Right. So as I said, we will be executing it a little bit differently. Right. In the basic version of the class, if you recall, we used 365 Stealer, right, to execute that, which is fine. You can do that, but then you need to create that application, run it somewhere on a virtual machine, expose that to the internet somehow, right? So a lot of setup over there. So here we'll look into using Azure itself to execute your consent phishing attacks, right? So only using Azure resources, right? So what we will use for that is an application registration, of course, right? So you would need to create first have an Enter ID tenant to start with, otherwise you would never be able to use any Azure resources, right? So you need an Enter ID tenant, so your attacker tenant, let's say. In the lab, this will be the no more oil tenant, right? So in that tenant, you would create an app registration, right? Or you could do that in the target tenant if you already have a foothold in there. In there, you could create an app registration in there, right? Have some benefits from that as well. But either way, you need to create app registration somewhere, right? So this would be the application where you would try to trick a victim user into signing into, right? So this will be a multi-tenant application if you do that in your attacker tenant, right? Then aside from that, we will be using a function app. So this function app will be listening for the authorization responses from a target. So after a user provides the consent, they will send or will be redirected to this function app, and the function app will be listening for the responses, after which it will use the response to obtain an access token, right? And then we have a storage account. So this is where we will be storing the access tokens in a table. We'll show it in this graph. It might be a little bit more easy to understand. So we have our app registration, right, in our attacker tenant. You'll see everything in red here is in our attacker tenant, right? So you will have full control over that tenant to be able to set everything up the way you want, right? So we create an app registration over here, and then we send a login or an authorization link towards the target user, right? If they click on that, they will see, or they will first be asked to sign in, right? Or if they are already signed in, they will just instantly see the permissions that will be requested. So it will be listed over there. If they accept that and continue the complete authentication flow, the user will be redirected towards our function app, right, which will be listening for the authorization responses. And there will be a function on there called student X in this case, which will request an access token with the response from the user from Microsoft's login page, right? And the access tokens will be stored in these storage accounts, ICG storage accounts, in a table student X, so every student can create their own table in there. Right, so what have we provided already? We have already provided the storage account, right? This is already set up in the number old tenant, as well as the Azure function app as well, right? But you can create in that Azure function a new function, right? And in the storage account, you can create a new table for yourself, right? So the table will contain the access token, but also a refresh token. So you would be able to obtain new access tokens and be able to use the permissions for a little bit longer, right? And with these access tokens, you could then interact with the Graph API in our case, because that is what we will want to get access to, right? So how do you defend from that? Obviously, as we said, or as we showed, the recommended setting from Microsoft is to set it to allow user consent for apps from verified publishers, right? And only for selected permissions. So this is the recommended setting. So you could set it on this. Or you could go even stricter and require admin approval for every consent in your organization. Will depend on your policy and how well you can handle that in your organization. If you receive a lot of these requests, it might get a little overwhelming to always require an admin approval, right? But in smaller to medium-sized organizations, this might be something you want to go for if you want to have it on the strictest setting, right? Also, the other setting that we looked was to disable the application registrations in your tenant for the reasons that we said, right? Because that could be used for an attacker to create the app registration in your tenant, right? And use that for internal spear phishing, right? To be able to more easily gain these higher privilege permissions. And aside from that, obviously, if a user grants consent to an application, there will be some activity logged in the Android activity logs. We will look at that in a bit, maybe. So this can be used to detect consent as phishing as well. Additionally, also note that every time that a user consents to a new application that no one has ever signed into, it will create a service principal in your organization, right? So you will see that under the enterprise applications. It will show up there as soon as the first person grants consent there and tries to sign into that application, right? So that is also something that you might see. So if you go through the logs later on, you would see that it would create the enterprise application, and then the user would grant consent to that as well. So you will see both of these steps. So something very obvious that you could look at detecting, right? All right, so this brings us to learning objective 14, where we will actually perform this illicit consent grant attack, right? So we'll be starting from the this web application again, right? So let's actually go to that. So you will see that this is the same website that we used in a previous kill chain as well, right? So if we go back to the working with us section, previously we found some email addresses over here in a PDF file, but here you also see some other user accounts, right? And the one that interests us the most over here will be Ray in this case, because he's an application administrator, right? In normal use cases, you might find this on an organization's website, maybe not that specific for application administrators, right? But on LinkedIn, for instance, you would be able to find that maybe, right? That someone in IT is very skilled at Enter ID and is probably the one that has an application administrator role in a target organization, right? Or if you enumerate that some other way, right? So here we will assume that we know that this user is an application administrator, meaning that this user will be able to grant consent for high impact permissions as well, right? They will be able to provide this admin approval, meaning that we could go a step further and not only fish for these low impact permissions, but request some more high impact permissions to be able to see its Teams messages, for example, right? So let's copy that email address for later on. And first thing we need to do right now is to actually set up, perform all the setup that we talked about, right? So we need to set up this first, right? So let's start by, the first thing we need is the app registration. So let's look at that, right? So here I am signed in the no more oil tenant. So keep in mind this is the attacker tenant, right? We have full access to that in a real scenario, right? So let's go to Microsoft Enter ID and go to app registrations, right? And you'll see that there are a couple of them already here, but let's create a new. Let's call that student 6. So the name doesn't really matter that much in our case. The supported account types, by default, it will be a single tenant application, right? We don't want that. We want it to be a multi-tenant application because the user that we will be phishing will be in the oil corporation tenant, right? So we want that user to be able to sign into our application. So we make that multi-tenant. And then we also need to provide a redirect URI. But actually, let's first register the application and then add that later on. So if we now go to manage authentication, add platform, and then we select the web, the redirect URI over here will be pointing to our function app, right? So we have not created a function app just yet, but we will want our user that we are targeting to be redirected to our function app, right, after signing in, because this is where the authentication responses will be sent to, right? So let's configure it this way. Okay, so now we have an enterprise or an application registration, right? So what do we need next? We need some way to authenticate as this application, right? So let's actually create a new client secret. You could use a certificate if you wanted as well. Then let me use a client secret because that's a little bit easier to work with in our case. Let's give that a name. For instance, secret 6, expiry. Let's leave that on the default. Okay, and here it is very important that you copy the client secret value itself because you will never be able to see this anymore, right? This is the only time you will see that, right? If I would refresh the page, you would not be unable to request that. Obviously, it's not that that's big of a deal. You can always create a new client secret, of course, right? And delete the old one. Okay, what else do we need? If we go to the overview, we need the application ID, right? So you can think of this as your if the client secret would be, or if the the client secret for the application would be the password of the application. This would be your username that you need to sign in as this application, right? So it's called a client and application ID. So let's copy that as well. All right, and then we're almost done. One last thing that we need to do, right? We need to provide some permissions, right? So the permissions that we want to request, you will see that by default it will have user.read for the Microsoft Graph API. But as we said, we want some other permissions as well, right? So Microsoft Graph, we will request delegated permissions, right? And let's search for the chat.read function, right? This permission would allow us to read users' chat messages. So what does that mean? That are the chat messages in Microsoft Teams, right? So we would be able to see the chat messages of this user. We could request quite a lot more permissions as well, right? If we wanted that, we would be able to request permissions to read the mailbox of the user, even send chat messages or send emails, right? But obviously, the more permissions you add, the bigger the list that it will show to the user when they are trying to provide the consent, right? So it will be a lot more suspicious if you add a lot of them, especially ones that will stand out, like chat.read. If you add too much of these suspicious ones, it might stand out, right? And another one that we want to add is user.read basic also. This one, not really requiring admin approval. However, we'll select that either way, that we can at least, if we want that, list all the other users as well in the target organization. Always a nice one to have. So let's add that as well. So you will see all the permissions that we would be requesting right now. Right. So these are the permissions that we would request consent for. Right. So why is it possible to use a chat.read over here? The only reason that this will be possible is because the user that we will be targeting, this user, will have the application administrator role in the target organization, right? So they will be able to grant admin consent and admin approval, right? They are the user that will be able to do that. If we would target normal users, then this would not work because they would be requiring admin consent for that, right? But as we said in the slides over here, the application administrator is able to provide consent for everything except for the Graph API, right? And now I'm showing you that we are requesting permissions for the Graph API, right? But this is limited to tenant-wide consent, right? So this means that it would ask for application permissions completely on its own, no delegated permissions, right? So tenant-wide consent, the application administrator would not be able to provide. However, it would still be able to provide the admin consent on behalf of itself, right, on the delegated permissions, right? All right. So our app registration is actually done here. So next thing that we want to do is to set up the storage account. Right, so let's go to the Microsoft Azure Storage Explorer. So looking into this a little bit earlier as well. So what we want to do over here is first to connect to an Azure storage. Right, storage account. We want to be using a Sesh URI. Let's paste that in there. So obviously this is something that we have set up for you guys already, so you can use that. In a real scenario, you would be setting up your own storage account already, right? So let's use the one that we already have and connect to that. You will see that we will then get access to all the tables in here. You will see there are a lot of tables already from other students trying this out. So let's create our own table, call that student 6. All right, so the table was successfully created. You'll see that by default, obviously, there will not be any data in there, right? So, but this is where, after providing the consent, the access tokens will appear, right? And the refresh tokens. So that's all we want to do over here. So last thing we want to do is create the function app, right? So for that, let's go over here. Right, and we have created a script for that to make it a little bit easier to set up. So if you go to the tools directory, and then in here, ICG function app script. So we have a script over here, a PowerShell script, new ICG function. We can edit that to show you what's inside. But basically, if you're interested in that and using that for your own campaigns, you can look at how you can set this up, right? But this will contain all the code required to receive the responses and then store the access tokens in the table, right? In the storage account, right? So you don't really need to modify anything in here. You can just execute that. Let's import the script and then execute that with a couple of parameters. You want to provide your the name of your function. So for us, it will be student6, the client ID. So this is the application ID. Let's actually use the one that we copied previously. So this is the application ID of the newly created app registration in our attacker tenant, and then the client secret. All right. Let's execute that. We also provided the name of the table where it will want to store the information in later on. This will take a couple of seconds to execute. All right, so that is done. Okay. Next script that we have is the config x script. Let's look into that one. So here you will need to create a small modification. So here it will say student X. You can change that to your own student ID, right? And then you can execute that to create the HTTP trigger for your Azure function, right? This is what it will do. It will create an anonymous trigger, so meaning that it can be accessed without any authentication, right, with get and post parameters, right? So this is what we also want to execute that. So I've already modified the config for me and named that config6. So let's actually execute that. All right. And now let's actually check if the function was actually created correctly. So if we go to our attacker tenant, go to home, here you go to all resources, you will see that the ICG function will be there, the function app will be there. And under the overview, you will be able to see all the functions under this function app. Right, let's look for our function if it was created correctly. Sometimes it might take a while to create that. There you go, it showed up over here. This is the new function that we created, function 6. All right, so you don't need to do anything with this anymore because it was already completely configured with the PowerShell script, but you will see that there will already be an HTTP trigger on there as well with the config script that we executed. Right. Okay, so basically at this point in time, we have set up everything to execute this attack. Right. So all you want to do now is to send an email towards the target user. Right. So you can use your own email address to do that. Right. There will be a simulation running that if you send a link to that, it will open that and go through the consent flow completely. Right. However, we have already fished another user or gain access to another user's account previously, right? Remember in the first learning objective where we performed the device code phishing, we still have access to the refresh token of student L-Write, if you remember from the very first learning objective, right? We performed some device code phishing there. And so if we still have that refresh token, you can use the credentials of this account to send an email, right? So what we will actually do is request an access token for Outlook, request that. And if we activate that access token, we will be able to use CrashSpy, for example, to open the Outlook, the mailbox of this user, right? Since we have the refresh token, we can do this for quite a long time, right? Until the user resets their password or their sessions get manually revoked, right? As you can see, we are now in the mailbox of Thomas, right? So we can still use him to send an email towards the other user, right? This is optional, right? You can also use your own email address. I will be using the privileges of Thomas over here, since that is convenient to use. So this is the link that we want to send to the user. Right, and you will see there are a couple of things that we need to modify, right? So the client ID, we need to modify that one. So let's actually go back and let me see where I copied the client ID. So this is the application ID of our app registration that we created, right? And then the redirect URI, we also need to modify that one to this is what we want to modify it to. No, come on. It doesn't want to paste it manually. So let's remove that and paste it over here. Paste text only. Let me actually create that in Notepad. Just paste it in here, see if it's fine, right? So this is the redirect URI will be sent to our function app, right? Our function that we created. Let's copy that URI, delete everything over here and paste that in here. And now we want to give that a name, a subject, and we want to send this email towards this user. Come on, copy pasting is not working in my advantage here. All right, there we go. So let's send that out. Obviously, in a real phishing campaign, you might want to probably craft a bit more, a better email, right? With a more convincing pretext, right? So now, after a couple of minutes, you will see that the automation will actually go through the consent flow. It will provide us with access in refresh token as well in our table if everything goes right. But this can take some time. Let's give it a minute. Any questions in the meanwhile? No questions? That's fine, because it seems like we got our access token already, right? So if you see, can I zoom in over here a little bit to, seems like we can. So let's do that. So what did we receive over here? The access token and a refresh token of the user RayKU, right? So we could now use this refresh token and this access token to access the Graph API, right? We can, let me copy the access token over here. And let's look into the claims that this token will have, right? You can see it over here. So it's an access token as we expected for the Graph API, right? So we can see which user signed in, from which IP address they signed in, and which permissions we have. So seems like we did get the chat.read permissions as we requested, because this user was able to provide admin consent to that, right? So let's actually use that access token. Let's store it in a variable, right? And now we would be able to connect with that token to the Microsoft Graph API. Right, as you can see, we are connected. Okay, so the reason why we requested this specific permission, chat.read, was because we wanted to see the Teams messages of this user, right? So we can request the Teams messages of the user using the Microsoft Graph API or the Microsoft Graph PowerShell module as well, using the get mg chat command. So let's do that and see if we can see any chat messages of this user. So these will be Microsoft Teams messages. Okay, it took some time, but we did get the chat message. So yeah, fairly useful output over here, right? We see the chat message and that is there. However, we have an idea of that. So let's actually see if we can actually view some more information about the chat message. All right. So this is a chat channel actually. So one-on-one, meaning that there will only be one user on there. It's not a Teams group chat with multiple people in there. And now we are using the get mg chat message command to view the actual messages in this conversation, right? In this one-on-one conversation with this other user, right? And we see that there are two messages in there, right? We have this one, and we also have this one, right? If we go to the top one, we will see that this one is actually deleted. So it was deleted, so we will not be able to see what's in there. The other one has deleted time not set, so we can probably see what is in there, right? But if we want to actually see that, it will be under the body parameter over here. You can see that's an object, so it's not really that useful to see right now. Let's actually change that. So for all the chat messages, let's view the body of that. Right, so we will see the first one is deleted, so there's nothing in there. The second one is also an HTML format, and here we can see the contents of that chat message, right? So here we have the chat message. So dear Carl, so the user that we fished this seems to be sending to the user Carl a password that was changed, right? Your new password is this, right? Please change it after your first use, right? Obviously they say that, but the user will probably not do that. They will probably just save that and don't change that, right? And if you have any requests regarding VM operations, just send them to Adam, right? So this provides us a little bit more useful info. So we have the password of a user. Which user is called Carl. We don't really know if there are any users named Carl yet. So let's actually use the get mg user command to list all users where their name contains Carl. And if we do that, we should see there is one user that is actually called Carl, right? This one also has it in her name, but this seems probably the user that he was chatting to. So this is the email address of the user Carl, and we have their password as well, right? Awesome. Let's actually see if we can do anything with that. We can go to the Azure portal. Right, we are already signed in over here, but let's close that window and create a new incognito window. And as you can probably already expect, what is going to happen, we are prompted for multi-factor authentication, right? So the password still seems valid, right? Even though the administrator asked them to change it, but they didn't do that. However, multi-factor authentication is in effect on the account, right? So you will not be able to authenticate to that. And you can try to enumerate other applications, but you will see that most applications will require multi-factor authentication, so we will not really be able to gain access to that account just yet. However, we will show you another technique to still get access, right? But that was actually learning objective 14. We got access to the Teams chat of this user that sent a password to the user Carl, and we got access to these credentials of that user. However, multi-factor authentication was required for this user account, right? Any questions about the consent phishing that we did here, or anything related in this learning objective? So I see you'll probably have a question. So first to actually summarize what we did. So we used the exploration portal. So this is the website that we already previously found. We found an email address of a user on there, and we created a malicious application, an enterprise or an app registration in our attacker tenant, and use that for illicit consent grants, right? So for consent phishing towards an application administrator, Ray KU, which grants us access to the Teams messages of that user, right? Using the access token that we received. And that's provided us access to the credentials of Carl. However, multi-factor authentication is currently enabled on that. So a question is more about the automation that we used. Right? So they are asking how did we automate the sign-in using the consent phishing when multi-factor authentication is required on this user, right? So what kind of multi-factor authentication is used? So that will just be a TOTP token, so a time-based one-time password, right? What we did was, if you create add a multi-factor authentication method, you can select to use a TOTP token, right? And that one is just based on a secret key, right? And if you have that secret key, you will usually store that by scanning a QR code, and your authenticator app will be able to generate a six-digit code for that user, right? Every single time, and allow the user to provide it over here, right? So they will see that code in the authenticator app, right? However, if you have the secret key, which Microsoft will communicate to your authenticator device with the MFA code, you can use that to generate every time you want this TOTP code. And so that is what is happening in the background, if that makes any sense at all. Right, I will show you. Can I show you that easily? If I go to my account, security info, it's a little bit hard to explain without an example, so let's actually show you that. Oh, it seems like I need to approve multi-factor authentication first. Okay. Let's let it load for a second. Okay, so if we add a new multi-factor authentication method, you can select Authenticator app over here, right? It will always recommend you to use the Microsoft Authenticator app, but you can use something else. Let's say I want to use a different Authenticator app, right? Let's do that. What it will show you is it will provide you a QR code, but all this QR code actually does is it will provide you, or it will communicate the secret key to your mobile device, right? If I would add that, you would now have multi-factor authentication to the device, but I'm obviously going to cancel that. So you're not going to be able to use that. But if I would add that, I could use that secret key. This is the only thing that is actually needed to generate this 6-digit code, right? So every 30 seconds, they will use some algorithmic function where they will use this as input, right? Together with the current time, and it will generate the code, right? And Microsoft will also have the secret key, will also generate the code on their side, and we'll see if it matches, right? So if you have this, you can generate these TOTP codes. Right? So that's how it's automated. Okay, if that answers your question, hopefully. Let's continue then. So we saw that multi-factor authentication was required on the or enabled on the account of Carl, right? So before October 2022, you would be able to use basic authentication to sign in to quite a couple of services, right? With only a username and password, right? That's what basic authentication is. It will just use like an authorization header, for example, and it will only support a username and a password, but it will never support any type of multi-factor authentication, or it will not communicate any of the required information for a conditional access policy to, or for most settings of the conditional access policy to work optimally, right? So services like Office 365, Exchange Online used to be accessible using basic authentication, right? And the risk of that is that you cannot use multi-factor authentication in conditional access when you use basic authentication, right? So an example of that is SMTP, right? And SMTP is probably the only exception that you will probably see quite a lot still, right? By default, all basic authentication has been disabled, so you can't just easily use these legacy authentication methods to authenticate to Office 365 and Exchange Online anymore for most users, right? By default, will all be disabled since October 2022. However, SMTP is a little bit of an exception here because there are so much applications still using or relying on SMTP authentication, right? It will still, Microsoft will still have disabled that by default on all accounts. However, you will see that most organizations will have a couple of exceptions for that, right? So if you are familiar with the SMTP protocol a little bit, you will know that the authentication process is fairly simple, right? It's just sending a couple of messages to our SMTP server, right? And eventually it will authenticate by base64 encoding your username and your password and sending that towards the email server. Obviously, no way to enforce any multi-factor authentication in that process, right? Because SMTP isn't built for that. SMTP is a very, very old protocol and it's still used very, very much to send emails, right? That is what it is used for, to send emails. You will not be able to read any emails with SMTP. There are other protocols to do that, right? For instance, IMAP and POP can be used for that, but SMTP is to send emails. So where will you still see that enabled quite a lot in organizations, for instance, on their printers and their scanners? A lot of organizations have some kind of setup for convenience, right? You can go to any printer or scanner in the organization, put the documents in there, and scan that document towards with the scanner, and have that scanner send the document to your own email address or to some other email address, right? Very convenient to get a scanned document from your printer on your device and work with that, right? Because this is so convenient. It's like all organizations will be using that, right? Right, so a lot of organizations will still be using that with SMTP authentication. And on your printers, obviously, they will not support any type of modern authentication. They will not do any multi-factor authentication or anything like that. So if you want to have an Entra ID account and use that to send emails to other users in your organization with SMTP from your printer, it will usually just have the email address and the password configured on that printer or on that scanner, right? And it will be able to send emails from that. So for these use cases, you would need to create exceptions on your accounts to still allow SMTP authentication, right? So this SMTP authentication can be configured on a per user basis. Don't expect this to be enabled tenant-wide for all users anymore, or to have this enabled for a lot of users. However, there are usually still a couple of accounts in most organizations that will be enabled with this, right? So if we compromise a user or an account that has this enabled, even if multi-factor authentication is required for that user, right, and there are conditional access policies, you can still use SMTP authentication if that's enabled to bypass any multi-factor authentication or conditional access policies, right? Only to send emails, right? So it's very important. SMTP is used to send emails, not to receive them, right? So where is this configured in the lab? You will see that this will be configured for the user Carl. So let's actually show you that. In the portal. So let's go to admin.microsoft.com because you can't really enumerate that from Entra ID. Also note that it's like not really possible to enumerate this at all as an attacker either without being authenticated, right? You would need some kind of admin privileges to see which users are still allowed for SMTP authentication. Obviously, if you have credentials, you can just use trial and error and test if it is still possible, right? So if we go to users, active users, let's search for Carl. If we go to the email settings of this user, and then you would have a setting over here, email apps. If you click on manage email apps, you will see, come on. Okay, there it is. You'll see the email apps that are allowed, and you would see over here that authenticated SMTP is enabled, right? For all other users, this will be disabled. But for Carl, in this case, it would be enabled, right? So this means that we would be able to send emails as user Carl without any multi-factor authentication, right? Even though conditional access policies are blocking all access to all other applications using multi-factor authentication, right? All right. So let's look at something else first before we go into the next learning objective, right? So we know that we can send emails, but how would we actually take advantage of that, right? We could once again use the consent phishing technique. We've also already showed you device code phishing, right? However, there is still another very powerful phishing technique that's called adversary in the middle phishing, right? And the most known tool to execute that is EvilGenX, right? So that is what we will be doing in the lab, right? So we will be using EvilGenX 3. Note that it will still forward you to EvilGenX 2 on GitHub. That's just, if we go to that, you'll see on the EvilGenX 2 GitHub, this is actually EvilGenX 3, right? And this is a very, very powerful phishing toolkit, right? What this will do is, we don't have any graphics for that. Let me actually, let me show you in Paint what this actually does, right? So you would have a Microsoft over here, right? Then you would have your attacker over here, and you would have your victim user over here, right? So what would actually happen in a adversary in the middle attack, right, or what EvilGenX would be doing, is they will set up a malicious website over here. This is the malicious web application, right? And instead of sending a user a link to signing to a legitimate Microsoft application, they would send a victim user a link to sign in to a login page that looks completely exactly like Microsoft, right? But instead of hosting this malicious web page itself on the web server over here, it will just take every request that comes in from the victim, take that, and it will modify that into a request towards the legitimate Microsoft website, right? So it will take everything in there and it will just substitute the domain name, right, from the malicious website to the legitimate Microsoft login website. Microsoft will just think that this is a normal user that is actually accessing or trying to sign into Microsoft, right? So Microsoft would return the login page over there, which would be returned to the victim user, right? So what this actually allows you to do is, if you keep this flow going, right, the user would provide their credentials, for instance, they would sign in with their username and password, would be forwarded to Microsoft, right? And now Microsoft would say, okay, these credentials are correct. Now prove that you actually have access to the account by doing multi-factor authentication, right? So it would show the multi-factor authentication prompt. So what EvilGenX would then do, just forward that back to the user, and the victim user would see completely the legitimate Microsoft website, right? So from the perspective of the user, it is very, very hard to identify that they are actually interacting with a malicious website, because it will just look completely similar. It will act completely the same as the Microsoft application, right? They are actually, in fact, interacting with the legitimate Microsoft login page, but the attacker is in the middle, right? It will decrypt all the traffic and re-encrypt it and forward that to the user, right? So that is what EvilGenX will do. So after the user would provide multi-factor authentication, right, would provide, for instance, the TOTP code would be forwarded over there, right? At this point, Microsoft would return the session cookies, right? It thinks that the malicious attacker device will be the legitimate user signing in, so it will send them the cookies, right? So the cookies will be forwarded to the attacker. The attacker can then forward that to the user. They cannot set the cookies on the legitimate website, as of course, but the victim user can stay connected through the malicious website to the actual website that is signing into, right? And in the meanwhile, the attacker gets access to all of the session cookies that Microsoft actually provided, right? And these session cookies would obviously allow you to sign in directly to Microsoft yourself, right? And bypassing all multi-factor authentication, right? So this is what we will be doing in the lab as well with Evogenix, right? So this is explained in a little bit more detail over here, right? So we will capture the session cookies, and these can be replayed, right? Because the user will already have done MFA, so the cookies will actually be valid to access applications, even those that are protected for with multi-factor authentication, right? So the cookies specifically that we would want to target that are interesting for us are the ESTS art cookie and the ESTS art persistent cookie, right? If you have these two cookies, you can steal that in some way. In this case, we will steal that using adversary in the middle phishing. You can also dump them from the browser of the user, right? If you get access to these cookies, you will be able to get access to that account completely, right? So if you recall the authentication strengths, we had a couple of default authentication strengths over there. We had the normal of the multi-factor authentication strength, right, which allowed all types of multi-factor authentication. And the most you had also the passwordless multi-factor authentication methods, and the most strict one was the phishing-resistant MFA, right? So we would be able to use this technique to bypass all types of multi-factor authentication, except all the phishing-resistant ones, like the FIDO2 keys, Windows Hello, and certificate-based authentication. Why will we not be able to bypass that? Well, if we look back at our nice image over here, this website, the malicious website over here, would obviously be running on a malicious domain, so on an attacker controlled domain. So this would be, for instance, malicious.com would obviously be a very bad name, but let's say it would be malicious.com, just to provide an example, right? If you authenticate, if the victim user interacts with that malicious website, it would never allow you to authenticate with FIDO2 keys, Windows Hello, and certificate-based authentication. Why? Because it's on a completely different domain. These types of authentication will only allow you to authenticate to the legitimate Microsoft login page, right? They will detect, like the FIDO keys, will store an entry on the key for the legitimate login page, so login.microsoftonline.com, right? So, and if it's your device sees that you're on the legitimate login.microsoft.com page, it tries to authenticate you with FIDO keys, right? It will send to the FIDO key, I am currently on login.microsoftonline.com. Please do your magic to allow me to sign in, right? It will perform some cryptographic things over there. I have implemented this in GraphSpy as well. Not going to go into too much detail of that, but after that, the FIDO key will sign a response that will be sent back to Microsoft, and Microsoft will see that you are authenticated over there, right? But if the user is on the malicious website, and the browser would send, okay, I'm on malicious.com. Do you have any entry for that stored on your key? Then the key will not have any entry for that, so it will never be possible to sign into that. So that is what we mean with phishing-resistant multi-factor authentication, right? There's no way, even if you intercept all the traffic in the middle, you can't phish that, right? You would need quite a lot of access. You would already need access to the device of the user to be able to abuse any of that, right? Or you would need to steal a certificate and this private key, right? All right. Any questions about that? Okay. So let's look into learning objective 15, right? So we found credentials of the user column. We also know now that It is possible to send emails with SMTP as this user, bypassing all the multi-factor authentication requirements that would be set up on his account, right? So we're going to abuse that to send an email to Adam, right? And we will actually use adversary in the middle phishing, right? This is what Microsoft calls it, to steal the session cookies of Adam, right? That is what we are going to do. We will use evil Genix for that in the lab. All right. Let's actually start with this learning objective after the break. Let's take a 15-minute break right now. And then after the learning objective, after the break, we will start with learning objective 15, right? You have a question, I will answer that after the break, if that's fine for you, right? Then everyone will be back, right? All right. See you guys. All right, let's continue. Okay, so a question was, before we went into the break, how long are the cookies and the tokens stolen by EvilGenX valid for? Right, so if we use EvilGenX to steal the cookies, how long can we abuse those or use these cookies before they expire? So that depends on a couple of things. So it will never be um, com- completely predictable because there are some occasions where the session cookies will be um, randomly not valid anymore, right? So, for instance, you can configure that when there is a risky sign-in, that all the current sessions of the user will be revoked, right? Also, if you reset your password, for example, things like that can impact that. However, in general, if we go to the portal, something that I can show you is that you can, in theory, also control that with conditional access policies, right? So if you, in your conditional access policies, if you create a grant, a policy with grant controls, right? Then you can use the sign-in frequency, right, under the session controls, sign-in frequency to require periodic re-authentication, right? And then you can say, okay, every 5 days, the user needs to sign in again, right? Their cookies will not be valid anymore, right? So the default will actually be 90 days based on what Microsoft says here. But yeah, in general, quite a long time, except if something happens, like the user resetting their password or an administrator revoking all the sessions for the user, right? That can influence that. But in general, quite a long time, right? Long enough for us as attackers to do with that what we want, right? So let's actually look at how we want to set this up, right? So if you want to do this type of attack in a real assessment, you will, unlike the consent phishing and device code phishing, where we are abusing the legitimate Microsoft login page, for this type of attack, you will need to do some kind of setup where you will be hosting a malicious website yourself, right? So for that, you would need to set up some DNS records. You would need to register a domain, set up some DNS records to point that to your malicious website, right, where EvilGenX will be running. And you will send the link to that website to your attacker, right? So in the lab, we will be using an internal DNS server. In a real assessment, you would actually set up, register your own domain, right? But for lab purposes, to ensure that not everyone just has to buy a host name or a domain name, we will use an internal DNS server. So if you go to this location, it's all described in a lab manual. This will allow us to control or create a new DNS zone in our lab that will be used by our student VMs as well, and by or more specifically, it will be used by um, the simulation that we have running in the background. They will use these DNS settings to be able to resolve our malicious host name, right? So if we go to zones, we can add a new zone. Let's name that student6.corp, right? We already have that zone actually, so let's edit the current zone so you can see that. And you would need to set up a couple of things, right? If you purchase a domain on at your domain registrar, you will be able to create DNS records, obviously, right? Probably don't need to explain that much. But things you will want by default are an NS record and the SOA record as well, right? You just point that to your DNS server, right? So that other DNS systems will know where to actually find the DNS server that can resolve the subdomains, right? And then there are two other domains that we need, subdomains that we need. We will create a login record, an A record. So that will then be login.student6.corp, and that will point to our attacker machine, right? So our attacker machine is this one. So if you look at the current IP address of our device, for me, it will be this one ending with a 6 because I'm student user 6. For you, it will be a different one. Right? So you create your DNS record, an A record for login.student6.corp, point that to your attacker machine where you will be running evilgenx, right? And the same for the www subdomain, right? Also point that to your student VM. When that is in place, we can actually run evilgenx, right? So it's already available in the tools directory, right? So it is a command you can run it. You can run it with a custom directory where your fishlets will be stored. And in evilgenx, fishlets are the actual configuration of the websites that you actually want to target, right? So if you go to evilgenx fishlets, you'll see there are some YAML files that contain configuration to target all kinds of specific websites, right? In this case, we'll be using the Office 365 fishlets. You can create your own fishlets as well, but if you look into that, you don't need to understand most of this. You can use the one that is available in the lab, and there will also be publicly available fishlets that you can find on GitHub, right? You don't really get any nice syntax over here, but what will you see in that if you open that? You'll see the actual hosts. So the subdomains where evilgenx will be listening on. In this case, it will listen on the login subdomain, and all traffic sent to the login subdomain, so login.student6.corp, will be forwarded to the login subdomain of the legitimate microsoftonline.com website, right? And everything to www will be forwarded to office.com, right? So that is what it will be intercepting, right? And then it will be using some subfilters. So subfilters are basically telling evilgenx everywhere you see this domain in a response, login.microsoftonline.com, replace that with our malicious host name, right? Right, replace the legitimate host name with the malicious host name, right? So this is to ensure that all the links in the web page where login.microsoftonline.com is actually placed in the legitimate web page will be replaced with links to your malicious website, like login.student6.corp, right? Otherwise, if a user would click any link anywhere, they would be redirected to the legitimate website, and we don't want that, right? Then you have some out URL. So this is basically where it will detect that the user has actually signed in, right? So after completing the login process, the user will usually go to this web page, KMSI, right? And there will be some tokens that we want to capture, right? So there will be cookies that we want. So these are the ones that we are interested in, ESTS out, EST out persistence, and we will also take these two for completeness, right? And we will also capture credentials. So it will also look for everything looking like a password parameter in a post request, right? All parameters in post requests that pass through evilgenx with these keys, we will capture that as well, right? So login and username and password. so that we also have the clear text credentials. Right? So this is the configuration that we will be using. So let's run EvilGenX. We will be running it with the developer flag. This will run it with a self-signed certificate, right? Because otherwise we would need to request a legitimate SSL certificate, right? Since this is an internal lab just for testing purposes, we can just use a self-signed certificate, right? In a real assessment, you obviously want to set up HTTPS, otherwise your users might get a little bit suspicious, right? Let's actually execute that in this prompt because this has a black background. It will be a little bit nicer, as you can see, right? So you see that we have the Office 365 fishlet already enabled because I was testing some things previously, but we will disable that in a second. First thing that we will do is do some configuration, right? So we will configure a domain name, so student6.corp. This is the domain that EvilGenX will know that it is listening on, and we will also set its IP address so that it will know that as well, right? This is the public IP address where EvilGenX will be listening on. Then we will set the host name of the Office 365 fishlet to student6.corp. Right, so you'll see that this actually disables the fishlet that was previously enabled, right? So we'll configure that hostname over here, as was the case previously already, but just showing you how to do that again. Let's actually confirm that this is the case. So with fishlet get hosts for the Office 365 fishlet, we will now be able to see the actual DNS records that you will need to configure, right? So the Office 365 fishlet in its configuration, if you go over here to its host, you'll see that it is configured to create a login subdomain and a www subdomain, right? So it will prepend these subdomains towards your domain that you will be using, student6.corp, right? So you need to ensure that these point to EvilGenX, which we already did, right, with our DNS settings. So now we can actually enable the fishlet, the Office 365 fishlet. Okay, so now it is actually enabled. So it will have the web page, the web server listening, and it will intercept all requests, incoming requests, and forward that to Microsoft.com, right? So now all we need is a link that we want to send to our victim users, right? And in EvilGenX, this is called a lure URL, right? So if we create a new lure URL with this command for the Office 365 fishlet, let's actually see it created a new URL with ID 3. So let's get that. URL, and this is actually what we will want to send to our victim user, right? So we can send that to our victim any way that we want, right? We mask it as any type of pretext, right? But in our case, we will be sending it as the user Carl, right? Because remember previously we found that user Carl had SMTP authentication enabled, meaning that it's good we can send emails as that user with its username and password, right? Okay. So let's send that email. Let's create a credential object with the username and password we got for the user Carl previously, right? Let's take that phishing link. So that's in a variable. And let's actually send the email, right? So we can create this mail parameter objects, right? So we define the SMTP server. This is the SMTP server from Office 365 that Microsoft will be using, right? We set the port 587 to use TLS, right? Use SSL. And the credentials that we provide are the ones from Carl, right? So we will send the email from Carl to Adam. So where did we get this? So previously we saw that the Microsoft Teams messages that we enumerated, right, they contained the credentials of Carl, and it also stated for all requests that you would that the user would need to send to the user Adam, right? This was the email address that was in there, right? So we will send them a new email with our phishing link, right? So let's actually send that email. Okay, so we sent that, and now we will wait a second in EvilGenX until the user actually visits that link, right? So we see some things showing up already. So we see that the user visited our phishing link. You can see its user agent and its IP address. It's probably trying to sign in right now. So let's wait a little bit longer. So you can see that we did this previously already. But we're waiting for the tokens for our third session. Seems like the user is taking its time here. Any questions in the meanwhile? Just to be sure, let's send that again. Should work from the first time, to be honest. All right, there it is again. Seems like the automation might be having some delay right now. But luckily we did this before the session as well. So we can actually use one of the previous sessions where we actually did capture all the information, right? So after the user goes through the complete authentication process, you can check out a specific session where we captured everything, right? So if we do this, for instance, for session 2, we will see that it will store, as we configured in the fishlet, the username and the password for the user, right? Additionally, it will also store all the cookies. So the question is, why are we attacking Adam? The reason why we are attacking Adam is because we found its email address previously. So if I go back a little bit, right? So we enumerated the chat messages of user we got access to previously, right? And here we saw the password of the user Carl, and the administrator is also saying, please send your VM operation request to the user Adam, right? So we know that this user will probably have some kind of connection to the user Adam in his organization, right? So we can probably take advantage of that, right? To act as Carl, to actually make this user believe that we are Carl and get something out of him, right? Like making him click a link and things like that. Awesome. So we have the username and password of the user Adam, right? So I can actually take these right now and try to sign in with that, right? Oh, not like that, of course. Let's try to sign in with the credentials of the user. And you will see, obviously, that once again, multi-factor authentication is required, right? So that's why normal phishing attacks where you only capture the credentials would not work. That's why we're using the adversary in the middle technique, because now we also have the cookies of the user. So we could import these cookies in a new browser session and use that to bypass multi-factor authentication and gain access to the account of the user, right? Because the user did multi-factor authentication itself, right? So how can we import these cookies? Well, we can do that manually from the browser, for example. So let's close that one, a new one. So we could inspect elements over here, go to application. If you were on the login page, you could manually add all your cookies over here, right? So you could type them in manually if you wanted to. However, there is a little bit of an easier way to do that. Right? You can use an extension for that. So if I go to extensions over here, manage extensions, I have already imported that one. But in the lab manual, it will say how you can add this cookie editor extension, right? So if you enable the developer mode over here, you will be able to upload custom extensions. And the one that we want is this one, cookie editor. So you can drag and drop that one over there, and it will then install the cookie editor extension, right? So if I go to a new incognito window, you can see I've enabled that so that we can use that from the incognito window. And on the login page, Microsoft login page, we see there are quite a lot of cookies in there already. So let's delete all of these cookies. Right, so if you see all the cookies are gone now for the login page, and let's import some other cookies, right? The cookies that we captured from this user. Let's take that, paste them in there, click on import, right? And if we now reload this page, you will see that we are automatically signed in as a user Adam, right? So this is how powerful it is when you have the session cookies of the user, right? Cookies, if you steal cookies, they are even more powerful than access tokens or refresh tokens, right? Because the cookies can be used to generate new refresh tokens and access tokens as well, right? For any type of application, right? So not only for one specific application, so even for non-Foki resources, we would now be able to access that, right? Such as the Azure portal is a family of client ID application, right? We can still access that using the cookies, right? So cookies are very powerful if you are able to steal those. Right? So that was actually learning objective 15. Right. Let's look at the kill chain diagram where that brings us. We don't want to save that. So we were over here, we had the credentials of the user Carl, right? Multi-factor authentication was blocking us. However, using SMTP authentication that was enabled, we could, using single factor, with only the credentials, send an email as a user call, right, towards the user Adam, for instance, right, which was also protected by multi-factor authentication, right? But using EvilGenX, the phishing link that we sent to the user Adam, the user signed into that, right? It would see the complete authentication, the complete legitimate login website of Microsoft, only hosted on a different domain, right, on login.student6.corp. They would sign in there with their username and password, and even go through the multi-factor authentication process, right, which gave us the cookies of this user, Adam, right? So we could then access the portal from there, and if we want, we can also extract the access tokens now from the browser, right, to gain access to the CLI. Okay. Any questions about EvilGenX or the attack that we performed, any other technique in this learning objective? If not, then we will continue to the next one. So partners and solution providers, right? So CSPs, cloud solution providers. If you are in a smaller organization where you don't have the in-house talent to set up Entra ID and Azure resources for yourself, you will probably rely on some kind of partner, so a Microsoft certified solution provider or any other partner to manage your environment, right? So you want to give that partner some kind of secure access to your organization, right? So this would usually be a managed service provider, such as an MSP, right? Could be resellers, advisors, and so much more, right? Microsoft actually provides some functionality to do that, to establish these kind of relationships a little bit easier, right? So a global administrator or a billing administrator, these are the only two roles that will be able to look for partners in the partner center, right, and establish a contact over there, right? So there are a couple types of partners, right, you could work with. One type of these partners would be, or one method to do this is you could just invite your partner as a guest using B2B collaboration and invite them in your tenants and give them all kinds of privileges that they need, right? You could do that. However, there is a more streamlined approach to that, where you could go through the partners center and add that user as a partner in there, right? So there are a couple types of partners that you could have. You have the advisor, right? So this one is very high privilege, right? So if you use the advisor partner type, they will by default get global admin and help desk admin to your organization, right? Previously, Microsoft also had the DEP, so that all one also had global administrator by default, so delegated administrator privileges was that. So that one is now being replaced by GDEP, so the granular delegated administrator privileges, because DEP was a little dangerous. It provided global admin by default and things like that, right? Now, granular DEP will allow you to customize which privileges a user would get, right? It's intended to manage Azure resources and also have some limited access in Microsoft 365 Admin Center. However, if you you can still provide them global admin privileges, right? And then it would still be very, very high privilege. But now at least you have some granular control over that with GTAP, where you can select the least privileged roles as well, right? And you also have the normal partner type. That one is a little bit similar, mostly used for managing Microsoft 365 Admin Center as well, not so much as Azure resources, right? And there you also have some more granular control. Could also provide global admin privileges there, but also not by default. Yeah, comment is you can also just make an account, name that admin at company, and then just provide that global admin and owner on your root management scope. Yes, there are definitely organizations that will be doing that, right? So Microsoft recommends using these partner types to have some more granular control over that and to allow you to do it on a little cleaner way, right? But obviously, still, if you are a managed service provider, right, and you have this kind of control over quite a lot of organizations, you will have a big target on your back for threat actors, right? It's very, very useful for an attacker to compromise in an organization that has access to quite a lot of other tenants, right? Because they instantly get access to all the tenants managed by that service provider, right? So really a classic supply chain attack, right? There are actual threat actors that take quite a lot of advantage of that. Right? They will specifically target big managed service providers, knowing that by compromising them, they will get access to all of their clients as well, right? So therefore, that was actually the biggest reason why Microsoft came with the granular tab, right? Because before that, a lot of partners just had global admin in a lot of their organizations' tenants, right? Midnight Blizzard is one of the most notable threat actors that actually goes after these MSSPs or the managed service providers, as we have seen from cases in the past. Right. So there are two ways to actually manage your solution providers. You can go through the partner center, and there you have the possibility to use granular tab as we provided, as we described over here, and these other types, right? So from the partner center. However, for Azure resources, there is a little bit of an alternative approach you can take, and a more recommended approach as well, where you can use Azure Lighthouse, right? So it's different than the partner center, right? It's not using any of these partner types. And it also allows you to provide more granular access to Azure resources, right? Where using the roles from the partner center, you would gain quite a lot of access to everything, everything in Azure, right? Here you can actually define with Azure Lighthouse, as we will see, to provide access to specific subscriptions and even to specific resource groups, right? And the main selling point of Azure Lighthouse is the fact that the customers actually stay in control of what their partners can access, right? So the access to the subscriptions and the resource groups is completely configured from and maintained from the tenant of the customer itself, right? So as Microsoft puts it, customers maintain control over who has access to their tenant, which resources they can access, and what actions can be taken, right? So it's used a lot by partners to manage resources in their customer organizations, also sometimes used by multi-tenant organizations, right? You have also a Microsoft 365 Lighthouse, so this provides a little bit of the same type of services, but then for Microsoft 365 services, right? So here we will be looking specifically at Azure Lighthouse in the lab, right? All right. So one big difference over here is that the managed service provider, so the partner itself, will never really have to sign in to your the tenant of their customer as well. They will see the resources that are provided access to them in their own home tenant, right? So in the tenant of the service provider, they will now see all the resources and subscriptions, the resource groups that were shared with the partner by the customer in their own tenant, right? So they don't need to even to sign into the tenant of the client organization that they are managing. They can see the resources and manage them directly from there in their own tenant, right? All right. So what you will see is that you are not able to actually provide data actions using Azure Lighthouse, right? That one is defined over here. So here you can actually see all the roles that are supported, right? So it will be all the built-in Azure roles. You cannot use any of the customer roles, right? So after you onboard resources and subscriptions in the organization of a partner, they will see them in their own tenant, but only the users that you actually specifically grant access over these resources will be able to manage them and see them, right? So all the built-in Azure roles will be supported. However, everything that will somehow allow a user to gain data access, all of these roles will not be allowed. So that means that custom roles, the owner role, and all the classic subscription administrator roles will not be available, right? Any roles with data actions will not be allowed, and any roles with the star/write or star/delete permissions will also not be allowed over the Microsoft authorization, right? So if you would have write access over the authorizations, then you would be able to escalate your privileges as well, right? All right. You can also use PIM to activate access to a specific resource. So very, very good as well, right? So some things that we skipped previously. Yeah, obviously to set this up, you would already need quite a lot of privileges over a subscription or a resource in a target organization, right? So the customer needs to set this up from their side, right? And they would need the owner role over a subscription to be able to add a partner or use Azure Lighthouse to allow a partner to access their subscription or resource group, right? Or a user with the role assignment/write privilege will also be able to do that. The customer, obviously, not everyone in the target organization will see the subscriptions, the resource groups, the resources in there. That's only available after the specific user or group in that service provider tenant is provided read access, right? It works completely the same as with you would otherwise expect access to resources to behave, right? So very interesting. It's really, really made to manage resources and not actually to access them, right? So you would be able to create key vaults and to modify them and manage storage accounts, but you would never be able to see actually the secrets or extract the secrets from the key vaults or extract the data from your storage accounts, for example, right? Because all of these permissions you would not be able to assign, right? Let me actually show you how this is configured in the lab. So if we go over here, go to service providers. This is where Azure Lighthouse can be configured. Seems like we're in the wrong tenants. Let me quickly switch that towards the all corporation operations tenant, where it is configured. Service providers. So in the all corporation operations tenant, so this is a different tenant that we have not accessed yet. So this is the last tenant that we will be trying to gain access to in this lab, right? You will see that all corporation is configured as a service provider, right, over a specific resource group, right? So if you click on that, you will see that it will provide access to some kind of part of the ops subscription, right? Not on the complete subscription. We will see that later on. You will see actually that there are some users that are provided roles in the other tenant, right? So Adam is a user that we previously compromised using EvoGenX, right? It will have the reader and the Azure Arc VMware VM contributor roles over a specific group of subscriptions, resource groups, or resources itself, right? So where can we actually see that? If you go to the delegations, you will see over here that the FFDB machine resource group is provided, is delegated access to some users from all corporation services, right? So from the all corporation tenant, right? Which specific roles does the user get? Azure Arc, VMware VM contributor, and the reader role, right? You can see over here, this resource group has a couple of Azure Arc machines, which we will be looking into later on, right? So this is how it is configured. All right, so let's actually look now what we can do with that as a user Adam, right? So if we would go to all the resources, you would see while we are in the all corporation tenant, we do have complete read access to all of these resources from within the all corporation tenant, right? Even though these are resources from another tenant, right? These are resources from the all corporation operations tenant, right? So you would see them completely in your own tenants as if they were from within your own organization, right? If you click on them, you will see at the top here, it will say it's in a different directory, right? You have access to resources in more than one directory, in the operations directory, right? So the question is, in a production environment, have you accessed an Azure VM, but were blocked from installing Azure CLI due to firewall permission prompts? I faced this issue while running Python tools as well. I've not actually run into that scenario specifically, I think. All right. If we continue with the lab in the meanwhile, we can obviously enumerate all these resources directly from the Azure portal, but if we want to use the Azure PowerShell module, then we will need some access tokens, right? So where can we get the access tokens? From the local storage, as we've done, no, not the local storage, the session storage is where it is. Right, so if we take an access token from here for the user, let's confirm that it is actually for the ARM API. Seems to be, right? For the user Adam, how long is it valid for still? Probably not that long anymore. Not really sure, we will see. Let's store that access token in a variable. And authenticate with that user. All right. So we seem to be connected. We see that we also have access to a subscription, and note that even though we use an access token from the home tenant of this user, right, from all corporation, we still see the subscription in the other tenant, on the operations tenant, right? And if we use get AZ role assignment, get AD resource first, you will see we have access to quite a lot of resources, right? And it will just completely show up as if these were resources in our own tenant, right? So we have access to quite a lot of run commands objects. We have access to a machine, a hybrid machine, right? This is an Azure Arc unrolled machine. We will see that later on in a little bit. It's called FF machine. What else do we have access to? Towards an SQL server instance. So on the machine, Azure Arc enabled machine, Azure Arc is also used for as an SQL server, right? To import that SQL server instance running on the machine into Azure Arc as well. We will look into Azure Arc a little bit later on, right? But that is the access that we see over here. So how can we actually enumerate that these are actually resources in another tenant and not in our own tenant? So if we list all the subscriptions, you will see that there is only one subscription that we have access to, the ops subscription, right? And you will see that there is a home tenant ID, and then we have a managed by tenants ID, right? So the home tenant ID, this is not our home tenant, this is the home tenant of the ops subscription, right? And the managed by tenant ID is the tenant of our user, right? So our manager user that has access to resources in this tenant, right? So users in this tenant manage resources in this subscription, right? And the subscription in this tenant, right? So how can we resolve that? There are a couple of ways how you can resolve that, right? It's not really that documented publicly. However, you can send a basic graph request. So if you have an access token for the Microsoft Graph API, as any user, it doesn't really matter. Anyone can do that for any tenant. So even from an attacker tenant access token, you would be able to do that. Right? If we send a custom API request towards this, using this API call, right, tenant relationships, find tenant information by tenant ID, and we provide it with the tenant ID of this over here. If we send that request, we will see the name of that tenant. So it's in the all corporation operations tenant, right? All right. So this is where we can get some sense of the fact that Azure Lighthouse is in use, right? We can also use this command, get AZ manage service assignments. It's the fact that it returns a result indicates that there is a tenant that we have access to, right? A different tenant that we have access to. It is not, or there is a resource group, right? This resource group that we have access to. All the other information is not that useful for us. It doesn't provide us that much information because you can see a lot of the properties are like not even filled in. It's useful information like the tenant name that we enumerated previously. However, here we could see that we have access to this specific resource group, right, and the different tenants. So let's actually list the role assignments that we have. So as we already enumerated previously, we have the reader role over this resource group, right? And we have the Azure Arc VMware VM contributor role over this resource group. Okay, great. So what is this Azure Arc that we have been referring to a couple of times already? That is actually something we want to cover in the next learning objective. So it seems like we missed a couple of slides here. Well, I was showing you that we went through most parts of the learning objective already. But obviously, as I stated previously, it is not possible to access any data or perform any data actions over resources when using Azure Lighthouse. However, Microsoft does warn in their documentation that there are ways that you could unintentionally grant unintentional data access permissions towards users with Azure Lighthouse. Like they provide an example of the virtual machine contributor role, for instance, who is able to read access keys of storage accounts, right? Even though, yeah, you probably assign this for the virtual machine contributor role to manage virtual machines, right? But if you grant that role over a subscription, right? If there are any storage accounts in there, that role will also be able to use the list keys action, right? With these keys, you would be able to then access the data from the storage account, right? So you can't access data from the storage account directly. However, you can list the keys, and with the keys, you can access indirectly the data in there, right? So these are some kind of things that we would still be able to abuse as an attacker if we see that Azure Lighthouse is in use anywhere, right? All right. So in the tenant, this is what we enumerated previously. The Azure Arc VMware contributor role also has some kind of unintended data access, since it will have the Microsoft.resource/deployment/read permission, right? So this means that we will be able to read deployment templates. So, and if you haven't really looked into deployment templates that much yet, you should probably look into that, because deployment templates basically can in a lot of cases contain sensitive information, sometimes even credentials, right, when deploying new resources, right? So, and credentials in these deployment templates can grant you, once again, some access to some data in the resources as well, right? So, unintentional data access, a lot of ways where this can happen, right? This is not what we will be abusing. We will be abusing the extension/write. So this is also something that we could be doing. So if you can install extensions on a virtual machine, you will be able to execute code on these machines as well. If you can execute code on there, for example, you can, if a managed identity is linked to that virtual machine, you could then use the privileges of that managed identity assigned to that virtual machine to, once again, maybe gain access to some data if data actions are assigned to that managed identity, right? So just to provide you a couple of examples, right? If that makes any sense for you guys. All right. So for now, what we will do, the Azure Arc VMware VM contributor role will provide us to the ability to run commands on Azure Arc VMs, right? We found that there was an Azure Arc, so a hybrid machine. So a machine where Azure Arc was installed on. We will look into what that entails in the next learning objective. But for now, we will just tell you that with this role, we will be able to run commands over that machine, right? Over FF machine, right? In this resource group, and this is the command that we will run, right? So the reason why we are executing this right now already is because this command will take about 10 to 15 minutes to complete, right? So what we will basically do is we will check all the services on this virtual machine and see if any SQL service is running on there, right? Because remember previously we enumerated that there is an SQL Server instance running on this machine, FF machine, right? So with this command, we can check if the SQL service or if there are any services enabled with SQL in their name, right? So it will take a while to execute. You will see there's a progress bar. It will go to the end and then it will start again. So it will take a while to execute that. In the meanwhile, let's look at Azure Arc then finally, right? So Azure Arc allows you to manage resources hosted outside of Azure, right? So things you can onboard in Azure Arc are, for instance, a virtual machine or a server on-prem. You can install an agent on that, on a server, and then you will be able to manage that server from Azure, right? From the Azure portal, you will see it in the Azure portal. You will see it using the ARM API. You can see it using Azure PowerShell and Azure CLI, of course, because they are also using the ARM API in the background, right? So virtual machine servers are one thing that you can onboard with that, right? So couple of things that this allows you to do is, for instance, if you onboard a virtual machine or a server, you can then use that to run app services, to run, for instance, web applications on that on-prem device, right? Or to execute your Azure functions, right? So if you want to have more control over where your Azure functions or your web servers are executed, right? You want to still use this functionality in the Azure portal, but you want to have control over where this is actually executed on your own virtual machines, for instance. You can onboard them in Azure Arc and then use Azure Arc to run these Azure functions or the web applications on your on-prem device, right? You can onboard Kubernetes clusters, even SQL servers, right? So we will look into that a little bit later as well. And also your virtual machines from VMware, Hyper-V, and Azure Stack as well. So to onboard your virtual machines, and then as you saw previously, you can use that to, for instance, execute commands on your virtual machines, right? You can completely manage your virtual machines then completely from Azure and use all of the, or not all of them, but most of the commands that you are familiar with from the Azure PowerShell module, for instance, to execute commands, right? All right, seems like our command completed over here. So we see that executing this command, there are a couple of SQL servers running on this machine. Okay, so this is interesting information that we will use later on. So Azure Arc enabled servers, what can you onboard in Azure Arc? So not only Windows servers, also Linux servers can be onboarded, right? So by installing an agent on them, and from that you can use it just like any other virtual machine. You can have some limited functionality available at least. So you can install VM extensions on there. You can onboard that in Defender for Cloud, right? So which might be interesting for some organizations, or you can access it with the ARM API and run commands on that, as we saw previously, right? So if you install these agents, there will be 3 services that will be running. You have the hybrid instance metadata service, right? The guest configuration and the guest configuration extension service. These last two will be running as local system, the other as as the NT service, right? So the instance metadata service will expose the IMDS API, as we saw previously in briefly in the one of the previous skill chains, right, where we got access to an AWS EC2 instance, right? There we interacted briefly with the instance metadata API to extract the user data, right? So installing this agent will also provide you with this access, right? So meaning that afterwards you could assign, for instance, a managed identity towards this Azure Arc device and assign roles to that as well, right? Actually, by default, if you install or onboard a device into Azure Arc, it will by default already get a managed identity, as we will see later on. So VM extensions can be installed on Arc-enabled servers, as we said. There are a couple of reasons why you might want that. So you can use extensions to collect logs and monitoring, like Microsoft Monitoring Agent, to get some insights or performance insight, right? For certificate lifecycle management in a Key Vault could be useful as well. Right? Post-deployment configuration. For that, you might probably use custom script extensions. From the basic class, you might already have be familiar with that term, right? So custom script extensions allow us to do quite a lot of fun stuff as well. And basically, if you have the ability to configure custom script extensions, you will be able to execute code on that device as well. Right. So there will be a link in the slide notes where you can go to Microsoft documentation to see all of the default extensions that are available. Right. One interesting thing is that for security, Arc-enabled servers can have an allow list and a block list of which extensions can be allowed, right? And you might think, okay, what kind of use does this have? Because if we have access over the Arc machine in the Azure portal, we can probably just enable that or change the allow list. Well, that's why the allow list and the block list is managed on the Arc VM itself, right? It's managed from the device itself. So you can only change that allow list and block list if you have already code execution on the server, right? So you see that Microsoft is actually really trying to keep this segmentation where the virtual machine is actually still in control somehow, and they're trying to make it a little bit harder to pivot from the cloud to your Arc-enabled VMs, right? Where by default, there is no allow list and no block list, so all extensions will be allowed, right? So you can have an allow list and block list, as I said. Even if you block custom script extensions, you can still use other extensions like OpenSSH, of course, to open the SSH port and connect to the server that way, or the admin center extension can also be used to once again gain access to that server itself, right? But obviously, if you have somehow the opportunity to run commands on the server, like we are able to do over here, then even if there is a block list on there, you would be able to obviously remove the block list or add other items to the allow list, right? At which point you probably don't need that, because if you can run commands, then you already own the device, right? So as I said, if you onboard a device to Azure Arc, a system assigned managed identity will automatically be created as well, right? So with the Azure Instance Metadata Service, so the IMDS, you will be able to obtain an access token from that and then use that to basically access all the resources, right? You can provide the roles to the managed identity, right? And the server can then request access tokens for the managed identity and access all the resources that are provided access. Right? So this is the endpoint that will be available. It will be a listing on the local host on port 40,342, right? Okay, so how do we abuse that? Yeah, obviously, if we are able to run commands on the device, right, it will be possible to pivot from the cloud to on-prem, right? So the ability to run commands or to install extensions, both of that can be abused to perform this type of lateral movement, right? Yeah, all the other stuff I already explained on the previous slides. So defense against this, well, not that much. Yeah, just using least privilege once again is going to be the key, right? So don't provide overly permissive role assignments in the first place if you don't assign uh, too much execute permissions or the ability to modify extensions over your VMs, then you would be able to mitigate that, right? But just note that installing Azure Arc on a on-prem device will already increase their attack surface, right? Because by default, the VM will just be on-prem minding their own business, but if you install an agent on there, suddenly you expose it to being compromised from Azure as well, right? You can use the allow list and block list, but do note that they can be modified locally if you have execute permissions as well, right? All right. So SQL servers. So Azure SQL servers will probably make the most sense to cover this slide first. So Azure SQL servers are based on the Microsoft documentation, a family of managed, secure, and intelligent products that use the SQL Server database engine in the Azure cloud, right? So you can basically have Microsoft SQL servers, but now manage them completely in the cloud. There are a couple of products that you can use there. You have the basic Azure SQL database. So this one is really database as a service, as the name implies. It's a platform as a service solution where the complete backend of the server is not managed by you. So Microsoft manages the virtual machine where it is running on and everything like that. They will keep the device up to date, right? Provide you serverless compute, so you will get access to your SQL Server instance and don't have to worry about patching the underlying operating system and things like that, right? The second way you can use it is using Azure SQL managed instances. So this is instance as a service. So once again, you can think of this as a platform as a service as well. And it allows you to perform easy migration of your on-prem SQL servers to the cloud, right? So what this would allow you to do is if you have an Azure or you have a normal Microsoft SQL server running on a virtual machine on-prem that is onboarded in Azure Arc, you can onboard that Microsoft SQL Server as well to be able to interact with that SQL Server as if it was an Azure SQL database, right? So you would have all the same functionality, even though it is running on your VM on-prem, right? And then you can obviously just have the regular SQL servers and install that on an Azure VM, and then you would also be able to manage that from the cloud. But then obviously you will still need to patch your operating system and manage the complete instance itself, right? So this is more infrastructure as a service, right? Azure takes care of hosting the virtual machine, but you still manage the operating system and all applications on there. So there might be benefits of using that one still, because you might sometimes need access to the underlying operating system still, right? You might want to interact with some other services running on the virtual machine or files that are stored on the device, right? So in that case, you might want to use the last one, right? So now we have explained all three classes. We will be mainly looking at the Azure SQL managed instances right now, because we noticed that it was installed through Azure Arc, right? So the way you would onboard that is you first onboard your virtual machine to Azure Arc itself, right? And then you can use SQL Server 2022. So only that one version is supported right now, and newer ones will probably also be. And you can onboard that into Azure Arc as well using the SQL Server extension, right? This is an Azure Arc extension, right? It will also onboard the SQL Server in the vendor for cloud, right? And allows you to access the SQL Server as if it was a normal Azure SQL database running in the cloud, right? By default, when you onboard the device, there will also be a server role, this one, and a database role, the other one, that will be created in your databases. Both will be provided complete system level access to the databases, right? Okay, so Azure SQL databases, as we said previously, they are just SQL servers, but managed completely from the cloud. So most of the enterprise edition features of the SQL server will be available, right? So patching, backups, and availability of the databases will be completely managed from by Microsoft, so making it a little bit easier. You will like to know that from the perspective of the SQL servers, it works a little bit differently, right? Because you don't have a physical SQL server instance anymore, right? So what you have over there is some kind of logical SQL server that will be created in the cloud. And in there, on the logical SQL server or database server, you can have multiple databases on there, right? So multiple databases, or it can be one database as well. So you can support Microsoft Enter ID authentication, right? So you can assign a managed identity to the database, and then it can authenticate with Enter ID as well. Okay. Any questions so far? So like other SQL Server versions, you will be able to use SQL Server links, right? And this is what we will be abusing in the lab as well, right? So SQL Server links, these were covered, I think, in the on-prem classes, right, where we abused SQL Server links quite a lot. So this allows you, for the ones that are not familiar with that, so SQL servers can be configured with SQL Server links. So that basically allows one SQL server to execute commands on a remote database, on a different database server, right? So it allows one SQL Server instance to query SQL commands or run commands remotely over that database link, right? So this is also supported by Azure SQL databases, right? So you can even create links from a normal on-prem SQL server to an Azure SQL database, right? Authentication types that are supported are normal SQL authentication and also managed identities and Entra authentication. So if you let two Azure SQL servers talk with each other, you might probably want to use something like a managed identity or Entra authentication for that. So the question is, if SQL servers or logic apps are managed by Microsoft or located on Azure websites.net, are these devices still within scope for testing a tenant without violating Microsoft's pen testing terms of service? Right, so if you look at Microsoft's terms of service regarding penetration testing, you will see that for the most part, they are fine for you if you test your own tenant, right? Or if a customer approves you to do that testing in their own tenant, right? So everything within their own tenants would be fine for to actually consider as to be in scope for the penetration test, right? But when you go further than actually testing the logic apps and the SQL servers itself, like you are actually trying to target the infrastructure underneath of that, so the servers from Microsoft, right? That would most certainly be out of scope, right? So unless Microsoft authorizes you to do a pen test on Microsoft themselves, you would not want to target their infrastructure, of course, right? But the databases as such, all the databases on the Azure SQL database from the organization, you can perfectly target them without any issues, right? Question is, why does the Azure Connected Machine Run command takes more than 10 minutes to execute in the backend? Yeah, this one is very, really very slow. So it will, as I understand it correctly, I don't know why it is this slow, because it should not really take that much time, right? Which is probably your concern as well. But it will create some kind of command execution object, right? The server will notice that the command wants to be executed on there. They will execute that, and then the output will be returned and put into that object as well. For some reason, it takes that long. I don't really know why. It's just really, really slow. It's not perfect for constantly enumerating through that. Probably if you encounter something like that during an assessment, you probably want to either just take it really low and slow and execute a couple of commands each one at a time, or you probably, if OPSEC is not your biggest concern, or if you have a very good C2 agent, you probably want to execute some commands that will give you some command and control over the server, right? To work with that a little easier. All right. So in learning objective 17, I will show you where we are in the lab right now. So we noticed that Adam actually has some roles, the Azure Arc VMware VM contributor role, through a resource group in all corporation operations, right, through Azure Lighthouse, right. This allows the user to execute commands on Azure Arc enabled machines such as FF machine, right. Since the commands that we are executing are so slow, we will not go through this manually, otherwise the session would go over time quite a lot, right? So that is why I will actually share with you guys. If you have the time, you can obviously go through that yourself manually. What I want to do, maybe I will just copy the last command And let me execute that over here. And then we will come back to that in the future. If it would finish before we are done going through that. All right. So I will show it over here in the lab manual because it is a little bit more straightforward to show you guys this, right? And we don't have to wait 10 minutes every time, right? So first command that we did, this was where we ended off the last learning objective, right? Was just to check all the services with net start and then selecting all the services containing the SQL keyword, right? So we see that these three services are running, right? As we already suspected because we saw that we had access or there were some Azure Arc enabled SQL servers visible in the portal, right? So here we would want to do some enumeration, right? In this case, we will directly go to into enumerating linked servers, right? So if you execute the select name from sys.servers on a SQL database or on an SQL server instance, it will show all the servers it has an SQL link established with, right? So what are we doing? We are using the Azure Connected Machine Run command to execute SQL CMD. So this is a program that will be by default installed on all servers where you install an SQL server instance, right? So to execute a specific SQL payload on the server, right? So we are enumerating all the linked servers on FF machine, right? And we will see by default the command will also return itself always. But we see we have an SQL server link with another server, SQL server instance that is called EDI, right? So this is a different SQL server which we have a link with, right? So as we said previously, if you have that link, you will be able to execute commands remotely on that other server, right? So to do that, we can just use this connotation, right? So the command that we will execute will be this, but instead of executing it locally, it will be executed at the EDI server, right? So the name of the other SQL server instance, right? So what will we execute? We will enumerate the SQL server links on the EDI server right now. So maybe the EDI server also has some links to another database, right? And we see that the EDI instance also has an SQL server link with a third SQL server. This one is called Azure SQL. So this one is probably not an Azure Arc enrolled device, but one of the classic Azure SQL databases, right? So now we can pivot through these links and we could go as far as we want to go, but we pivoted from the cloud towards an on-prem Azure Arc server where we can run commands, checked the SQL server links and found that there was a link with another SQL server, which has a link to another SQL server. So we pivoted to on-prem and then back to the cloud through a couple of SQL server links, right? Okay. So EDI has a server link with Azure SQL, right? So obviously you might first go for enumerating the tables and all the data on FF machine itself and then on EDI, right? We will skip that because that enumeration process, it doesn't really provide that much added value. But let's say we don't find anything useful in EDI and on FF machine itself, right? So what we would then go for is to check if there is any sensitive data stored in the Azure SQL database instance, right? So we can run this command, sp catalogs of the server name, that will be Azure SQL. What will that do? This will list the databases in this instance, right? In the Azure SQL logical database instance, right? we will see that there is the default master database and another one called Allcorp Logistics Database, right? So this one is obviously not default, so probably contains some useful information. So let's actually use the following command: execute sp tables x for this table name, the All Corporation Logistics Database table, to see what tables are actually listed in this database, right? So there seems to be a table named inventory in the All Corporations Logistics database. So we can, obviously, the next logical step would be to see what data is in this table. So let's just select everything from this inventory table on this database. And then we'll see that we will get one row which contains a URL, right? And this URL, if you look at that, seems to be for a storage account, right? So it seems to be a SES URI, right? Let's see. The command has executed completely, right? So here you can see an example of how the output would look like. So this is the last command. We only execute the last command to save some time, right? And you will see that the output is shown over there. Yeah, it's not really very nicely formatted, but you will see over here, this is the URI, the same URI we saw previously, right? All right, great. So let's actually copy that and go through the Storage Explorer and add that one. Add a storage account with the SS URI. You can use that one. Paste that in. So the extension plan storage account. Let's connect to that. And let's see what containers are in there. So there seems to be a container called logs and one analysis report. So the logs one is empty. And in the analysis report container, there are some files stored in there. We have a file named credentials.txt and then a folder Miro certificate. If we open that one, we see that there are a couple of files in there as well. Confidential details.txt and a certificate as well. All right, so we have a certificate, a confidential details file, and credentials. So let's actually download all of that. To there. To the downloads folder. Let's override the files that are already in place from previous testing and see what kind of information is actually in there, right? Downloads, analysis reports. So we have the credentials.txt, credentials for a top secret project on Miro. So this is an enterprise application. It can be accessed with this credentials. So clear test credentials of a user. And what else do we have? In the certificates folder, we seem to have a certificate, Miro certificate, and confidential details. Password for the Miro certificate PFX file is this: do not disclose or share with anyone, right? But you still got access to that. And if we see, it is found in a storage account called expansion plans. So this probably contains quite a lot of sensitive information about expansion plans from the All Corporation organization. Right? That was actually learning objective 17. Any questions about that? So to make it a little bit more visual, we executed commands on FF machine, right, which had an SQL Server instance installed on it. right? And this SQL Server instance had a link to another SQL or another server called EDI, on which an SQL Server instance was installed, which had a link to an Azure SQL instance, right? So these two, EDI and FF Machine, were both Azure Arc devices on-prem. So we pivoted from the cloud to on-prem, and then with this last SQL Server link back to a real Azure SQL instance, which was in the cloud again, which contained a SaaS URI, allowing us to gain access to credentials of a user called Lindia, as well as some certificates and the password for that certificate. All right. So now for the last learning objective of this session and of the lab. This is a very interesting one as well. So really probably the most interesting one of today's session. So please still pay some attention. All right. So SAML SSO. So SAML is a single sign-on option that allows you to access enterprise applications with the credentials of your Entra ID tenants, right? So there are a couple of SSO options, right? But SAML is probably the most common one that is used by most applications to provide SSO access, right? So single set of credentials to access your applications. You probably know SSO. SAML will be the most popular one. You can think of it as a little bit similar as OpenID Connect, right? Which will be using OAuth with access tokens, right? But SAML will work a little bit differently, right? It will use mostly XML-based tokens, so XML-based SAML responses or assertions, whereas with OAuth, we will be using access tokens and refresh tokens using JSON formats, right? Yes, indeed, OpenID Connect is also a very common one, John. Okay, so what do you need to set up SAML SSO? So obviously you need a high privilege account. Either a global administrator can always do that. But if you have the cloud application administrator or application administrator roles, you would also be able to create your application, your app registration, right, and configure SSO for that. Or if you have the owner role of an application already somehow and you don't have access to any of the previous roles, right? Then you would be able to configure SSO for that. Usually you would not be the one configuring that yourself unless you create your own applications, right? If you just want to integrate Entra ID authentication or SAML SSO authentication with a different application from a third party, then they will already have done the setup, right? But you will still need to do a little bit setup on your side as well, which we will see later on. So how does SAML SSO work? You will see that it is a little bit similar of an authentication flow as OpenID Connect. However, it uses different protocol, different set of standards, right? So we have a user that is trying to gain access to an application, right? In SAML terms, this is called a service provider, right? When the application receives sees that the user tries to access that, they will return a redirect to the identity provider. In this case, this will be the Microsoft Entra ID as identity provider, right? And it will generate a SAML request, authentication request, forwarding the user to Microsoft Entra ID, right? The user will then sign in on Microsoft Entra ID, right? And will Entra ID, after authentication, will generate a SAML response, right? That will be forwarded to the user, and the user will be redirected once again to the application or the service provider, right? The SAML response, you can think of that as your access tokens, but then for SAML, right? So just similarly like how the access tokens work, the SAML responses will contain claims, right, about the user. So it will, for instance, contain their username and other type of information about this user, allowing the application to identify which user actually signed in, right? Without actually having to handle the credentials of the user itself, right? It can outsource that to the identity provider, right? The SAML response is signed by a certificate, right? By the private key of a certificate, and that certificate will be stored in the service provider will trust that certificate. It will have the public key of that certificate, so it will be able to validate whether the SAML responses are valid, because it will be able to check the signature on that SAML response, right? And if the signature doesn't match, then it knows that the response was tampered with, and it will not trust that, right? But if everything checks out, right, the response was valid, and like in a normal scenario, the application would authenticate the user, right? It would know which user signed in there, right? So to configure SAML as a zone with a application, you would need to do a couple of steps, right? So you can add that application to your Enter ID tenant. It will be an enterprise application in your own tenant, right? So a service principal will be created in your own tenant, and by default, it will use a self-signed certificate for SAML responses. And in this case, the fact that self-signed certificates are used are actually more secure, because if you think about it, Enter ID will generate a certificate at its own site, and it will never ever share the private key of that certificate with anyone. You will not know the private key. It will just give you the certificate, right? You can import that certificate on your application that you are wanting your users to authenticate to, right? And then it can use that with the public key of that certificate to validate the responses, right? But the private key will never leave Enter ID, and there's no way to get it out of there. However, you can also use an external certificate, right? So you can create your own certificates and import that over there, at which point, yeah, if you created a certificate your own, then the private key will be somewhere, right? You can, for security, maybe delete that afterwards, but for a certain time, the private key will be exposed. And if you don't clean up your files afterwards, if someone finds that certificate and the private key, they will now have the ability to forge SAML responses, right? So that is what we call a silver SAML attack, right? Like for those familiar with the silver ticket attack, right? If we have the option, if we have the password hash on premise then of a service account, then we will be able to create forged TGS, so service tickets that are encrypted and partly signed by the password hash of that service account. So this is basically what is happening with Silver SAML as well, right? If we have the private key that is used to sign these SAML responses, we can basically create our own SAML response, right? Containing any claim that we want. We can claim to be an administrator, for instance, sign that and return that to the application, and the application will, the only validation that it will do is check, can I verify that signature? Can I verify that its signature matches with the content that is in there? And if that is the case, then it will trust all the information in there, right? And this can be can lead to privilege escalation, right? Or can also be used as a persistence method, right? So even if the users would reset their password, things like that. If you have the certificate, you can keep signing these SAML responses, right? So if the certificate would be compromised somehow, you would need to delete that certificate from your enterprise application and once again add a new one, right? Sets up SAML again. Which brings us to learning objective 18. So let's actually go to the Azure portal. Over here. So we found credentials for the user, Lindia, right? And it states here that this user has access to a top secret project in Miro. So if we just Google Miro, what is this? This is a public application. For some reason, it's in French over here, probably because the virtual machines is somewhere in France, right? So this is a public application that anyone can use to for some collaboration in their organization, right? You can create kind of dashboards where you can share your ideas. For some reason, a lot of the images are not loading over there, but this is not an application that we set up in the lab. This is a real public application that supports SAML authentication, right? Just to show you that it can really be any application that could be vulnerable to that, right? So let's start by using these credentials to sign in to the Azure portal, right? And in this case, you're probably expecting multi-factor authentication to block us, but this time, no multi-factor authentication required. You will probably also see these kind of discrepancies in real environments as well, where some users have multi-factor authentications, others do not have that. For some applications, it's possible, with other, it's not. Right? So this user is in the corporation operations tenant, right? All right. So let's go to Microsoft Enter ID. And let's check out our own profile of the user, Lindia. Let's look at the enterprise or the applications that this user has access to. So here we can see that this user has access to the Miro application and also a couple of other ones, but the most important one is here, Miro. So this is how we would be able to enumerate that. Where else would we be able to enumerate that? You can also go to, if you're signed in as a user, to My Apps, Microsoft.com. It will sign in, and you will also see over here that the Miro application will be there, right? So we could click on that, and then it will automatically sign us in to Miro as well, right? But we will not do that because we want to see something else first. So let's open Miro application over here. You can see the URL over here. Service Principal ID that's created over there. But let's go through that manually from the enterprise applications, right? So quick reminder, every time you want a user to sign in to some kind of third-party application, there will always be an enterprise application object stored in Enter ID, right? The service principal will always be stored there and created there. Even if it's just one user, there will be an enterprise application for that. Right. So we see over here the Miro one. So let's click on that one. And let's show you how it looks like, what it looks like if you configure single sign-on with SAML. If we go to single sign-on, you can see here is a simple step-by-step of the SAML configuration, right? And you will see in step 3, there will be the SAML certificate, right? So in this case, If we edit that, you will see that it will not be a self-signed certificate. Can you see that over here? Well, no, not really, but you can just import your certificates over here. In this case, we are not able to do that because Lindia does not have administrative privileges, right? But you can still see that the current active certificate has this thumbprint, right? Meaning that if we would have access to this certificate, we would be able, or the private key of the certificate, we would be able to sign some responses ourselves, right? Because Microsoft Enter ID also has this certificate and private key. So the target application would not be able to make any difference, see any difference between if the response was signed by Enter ID or by us, right? And recall, we do have a certificate over here, right? It's called Miro certificate. We extracted that from the storage account over here, right? So let's see if this certificate, this PFX file, has the same thumbprint as the one stored in the portal. To show you how you can confirm that, over here with get PFX certificate, we provided the path and it requests a password. Okay, so the password, where do we get that? In the same folder, there was a file named confidential details.txt, and here it says that the password for the certificate was secret pass at 123. Right, so let's paste that, and it seems like this is valid. And we get the thumbprint over here. If I copy that and go over here, you will see that this is in case the same thumbprint, indicating that this is very, very likely the same certificate, right? All right. So in this case, we know that we would be able to execute the silver SAML attack, right? But what would that provide us, right? We can check here in Miro, or if Lindia, the user that we currently have access to, if she already has access to some sensitive information, right? So if we just go to My Apps and we click to authenticate over there, we'll see we will be signed in over here. There will be a mind map and some untitled project over here. But even if we would be able to let it load, there would not be any sensitive information in there, right? So it seems like the user does has some access, right? Right, so indicating that the SAML SSO is working. However, the user doesn't have access to any sensitive information, right? So how can we enumerate which other users have access to the Miro application? Well, if we go back to the enterprise application under users and groups, we will see that Lindia has access, but there is another user, EA to CEO. This user, probably an account from the CEO, will also have access to Miro, right? But we don't have the credentials of this user. However, with the certificate, we would be able to forge a SAML response to gain access to that, right? So a remark is, in the third step of the single sign-on over here, there is an option to download the certificate, right? Yes, you can download that, but this will not contain, this is a .surf file, this will not contain the private key, right? So it will have the certificate, right? So the public information of the certificate, that's fine to expose. It will be contain the public key as well, right? So you can use that to go to the Miro application and import that so that it knows the public key of that certificate, and it knows it will be able to check the signature of incoming responses, right? But it will not contain the private key, right, of the certificate. So you can't just download that and get the private key out of there, right? All right. But in our case, the PFX file will include the private key as well, right? Which is encrypted with the password, which we also have, right? Okay. So let's execute the silver SAML attack. To do that, I will actually close everything out because definitely close that one because we will be using Burp Suite in a bit. And to save some RAM on the student VMs to ensure that nothing crashes, let's close all the other processes, right, that we don't need anymore. We don't need that one. And the other ones are probably fine. This one is duplicate. Okay, so let's open Burp Suite. It's installed on the student VM already. So let's open that. Seems like it's doing some mandatory update over here. Also can close this one as well. Don't need that anymore. Okay, so where was Burp Suite? There it is. Okay, so let me go to the proxy tab and open the Burp Suite browser. I will show it to you side by side. Then you might be able to see most of that, right? Let's actually open an incognito tab, right? Because we're going to Miro.com. And I am going to assume that most of you are familiar with a tool like Burp Suite, right? So it will just show you all of the requests that are happening in the browser over here, and we can intercept them, modify them, things like that, right? Okay, so let's log into Miro over here. And you will see there is an option over here for SSO. Let's click on that and it will ask us for an email address. So let's provide the email address of the user Linja because that's the user we have the email address of. Let's click continue and we will see that it will redirect us to Microsoft login page. Right, so as we expected in the SSO scenario, it will request for the password. So let's provide the password in there as well. All right, and before we continue, let's turn on interception on in the Burp Suite browser, so then it will just temporarily capture all the following responses, and then continue over here. So here we will see it will authenticate towards the Microsoft endpoint, so let's forward that one, and then we don't need that one. This one is the one we need. Or forward that one, yes. So post request to Miro.com, the /SSO/SAML interface, right? And here you will see the SAML response parameter, right? So it's a big blob of base64 encoded data, right? Let's copy that one and let's decode that with Burp Suite as well, right? So let's first URL decode that, decode as URL. And then decode that as base64. So you will see, as I said, it is XML data in there, right? So let's actually show you what is in there in a more convenient to see window. If I paste that in a random XML parser, right, and zoom in a little bit, you will be able to see what data is in there. So this is the SAML response. It will contain all the claims, right? So let's expand all the objects over here. And you will see it has a signature on over there. So it is signed, right? If we modify any value in here, the signature will not match anymore because the signature is a hash of all the data in here and then encrypted with the private key, right? So that's what the signature is. Right? So what information do we see in here? If I scroll up a little bit, this is fine. We have some assertions. All right, so we have a subject in here, right? So this is actually the username of the user that signed in, right? So this is how Miro knows which user is actually signing in, right? If we would be able to modify this, we would probably be signed in as a different user, right? What else is in there? You will see there is some information like the recipient. So where is this response sent to? So to the SSO endpoint of Miro.com. Right, so the audience is in there, and some additional attributes are also in there. Right, so we have the tenant ID, is this one, object identifier. We have the display name of the user in there. So a lot of claims about the user, right? So the email address of the user, all of that is in there, right? So with a legitimate SAML response, we can get all of the required information that we would need to craft a forced SAML response, right? So let's actually show you how we could do that. If we go to here, we will take this post request and we will send that to the repeater tab. Now we will just turn off interception. Right? You don't really need that anymore, but just so that we have this post request saved, right, for later use. All right, so let's actually close that window. It was an incognito window, so to ensure that we are not signed in anymore as user Lindia, we will remove all the cookies that we had previously. And now let's take this response and replace that by our forced response. So how can we create that? We can use a tool that's already on the student VM. It's called Silver SAML Forger. Right? So you can check that out. It's on GitHub, open source tool. And we need to pass some information to that, right? We pass it the generate keyword, and then we pass it the certificate that we wanted to use to sign the SAML responses, right? Obviously, it needs the password to be able to use the private key in there, right? And then the other parameters will all be visible in the in your legitimate SAML response, right? So if you would search for them, you would find them in there as well, right? So you have your IDP ID. If I would take that one and search and show you where you would be able to find that, it's this in there. It is your issuer in this case, right? So you would be able to find that in your legitimate response, right? So what also is in there, the recipient. So this is the endpoint that we showed over here. Once again, it will use that in the SAML response, right? The subject name ID. So in this case, instead of using the email address of Lindia, we will use the email address of EA to CEO. Why this user? Because we enumerated that this user also has access to Miro, right? So the response will contain this email address, tricking Miro into believing that we are signing in as this user, right? The audience, once again, we got that out of there. And then all the attributes is all of the rest, right? So we have the tenant ID attribute set to that. We have the display name attribute set to EA to CEO, and all things, everything that we found in our legitimate SAML response, right? So let's execute that command, and you will see it will generate for us a new base64 encoded SAML response. So we can copy that and go to Burp Suite again, right? So we will delete the legitimate SAML response. There we go, and paste in our forced SAML response. If we send that, we will see we will get a redirect to this location, but most importantly, it contains all of cookies, right? And in this case, we will see that this is because the user is correctly signed in. So it will probably use this as a session cookie, I would assume. So if you take that response, you can right click the response and use show response in browser to copy that URL. And then if we go to Burp Suite again and paste that into a new incognito window where we are not signed in yet, we'll paste it over there. And we will see we will automatically be signed in to the Miro application, right? So let's make it a little bit bigger. And if you see here in the bottom left, we are signed in as EA to CEO, right? So our privileged user, right? So this is a very, very cool technique, right? And we will see that there are some top secret operations file over here. So this is actually where you will be able to find the final flag of the last kill chain, where we will actually be able to see what the plans were of the whole corporation, right? Where we will now be able to see what their plans were from the beginning, right? So if we see over here, their plan is to exploit some mining operation in the Himalayas. As you can see over here, they did some calculations of what the impact would be of that. There would need to be 50 million people displaced, right? They would take 15 billion tons of oil from the ground, would have an ecological cost of 152 billion, right? And the summary is that it would cause irreversible and catastrophic loss to the local ecology and the global climate, right? And massive human migration. Therefore, it would be recommended to not perform the exploitation, right? However, the CEO seems to have signed off on this to start fracking in 3 months, nonetheless, right? So there you go. That is the final flag of our lab. Any questions? This SAML has some properties like OpenID Connect, like a nonce, where the service provider can check if the generated response matches the one with its request. Based on what we see over here, I don't think so. But even then, if there was a nonce, like you probably mean, let's go back a little bit. If there was a nonce in where the application would generate that nonce and provide that, return that to the user when going through the Enter ID authentication link, right? It wouldn't really matter because we can just capture that still, right? And include that in our response, right? Unless they already somehow request your username, right, and only allow that nonce to be matched to your username, right? But I don't think that is the case. A comment from Mimi Talks is the SSO allowed apps would be a good pretext with device code phishing. Yeah, definitely. So a question from Tony Lino. If you have problems in the lab, are we able to ping you for help over the next months before the exam expires? Of course. If you have questions going through the course, just ping me on Discord, send it a request in the channel, or send a request to the lab team as well, right? Any way you want to reach out to us, we'll be fine, right? So comment from Andrew is, so the best way to actually defend against the silver symbol attack would be to use a self-signed certificate, right? So yeah, in this case, I'd say that using a self-signed certificate would be a lot better because the private key is never exposed, right? But no, yeah, if a user has any of the high privilege roles, like I showed over here, global administrator, cloud application administrator, they could still add a certificate to that as well, right? So for persistence, it wouldn't really matter that much, but for initial access, if you really don't want to expose your private key anywhere, that would be a good option indeed. The question is, will Alta Security be creating bootcamps specific to AWS? We've had that request, right? But for the time being, I don't think that is the case. However, if we would want to do that, we will probably want to have an expert that is specifically, that's a lot of knowledge of AWS, right, to look into that. So maybe you might see that in the future. For now, the main focus will be Azure and on-prem AD, right? All right. So let's look into the defense summary now. So we will not spend too much time on that. We are going a little bit over time already yet, but we will just provide a quick summary over here. We try to cover a lot of the defenses already in the learning objectives themselves and during the when covering the material itself, right? However, we will provide a quick summary as well. If you have any questions about specific topics, we can go into a little bit more detail on that as well, right? So, just in general, some recommendations that will always be very strong, right? So, overall, conditional access policies is a very, very strong control, right? Especially if you use device compliance and location-based conditional access policies, which are a lot harder to bypass, right? So these will stop quite a lot of the attacks, right? Continuous access evaluation, of course, you don't really have that much control over which applications use that, right? There are a couple of first-party Microsoft applications that support continuous access evaluation, right? So that is also a good way of stopping token theft attacks, access token theft attacks, right? But also, once again, only if you have location-based conditional access policies configured that would observe the change when the access token is used suddenly from a different location, right? So from a location that would otherwise be blocked, right? Then continuous access evaluation would also be a great mitigation over there. Intra-ID protection obviously can be very, very useful and annoying to work with as an attacker. It will create risky silence, right? It will mark users as risky as well if it sees suspicious behavior on there. But mostly it will trigger alerts when you are signing in as the user from a location that is not familiar for that user, right? So if you're signing in from a different location or with a different user agent or a combination of that, that would probably trigger an alert. So be careful with that. In Azure, network restrictions will go a long way, right? Are very, very powerful. If you just already limit access to your key vault, storage account, logic apps, and things like that, only from your trusted locations or from locations where they are intended to be accessed, then that is also obviously very, very strong, right? So if you, for instance, have a logic app with a public URI to trigger that from the internet, right? You can restrict that to only allow it to execute from a specific IP address, right? So if you, for instance, only trigger that logic app from some type of server running on-prem, you can, and you know that that on-prem server will always have the same public IP address, you can restrict access to these resources from that as well. But even you can keep it within Azure itself, right? So where you are not even able to access the resources from the internet at all. And for instance, only allow it to, for an application in a specific virtual machine to access a specific logic app or a key vault, right? Very, very strong if you configure network restrictions, right? In the lab, we focus quite a lot on user identities to show you that it is a lot easier to protect these, and also to show that workload identities are a lot harder to protect, especially more expensive to protect, right? Because Microsoft wants to get more money out of you if you want to use conditional access policies for workload identities, for instance, right? User identities in general are easier to detect. You can use conditional access policies, use MFA on that. Not really possible for applications, right? Or the conditional access is possible, but multi-factor authentication is not. And it also costs extra to use that, right? However, sadly, users can be phished, right? And workload identities cannot be phished. So we still need to know how we want to interact with user identities as well, right? Because we showed quite a lot of techniques to bypass multi-factor authentication, even if it is in place, right? Conditional access policies, yeah, in the lab, they were using conditional access policies that mostly mimicked the security defaults, which is also very strong by default already, requiring multi-factor authentication for most application, for mostly everything already. We did create some exceptions to, for the sake of the lab, but you will see quite a lot of exceptions in organizations as well, right? If you enable conditional access policies, security defaults will not be available anymore, right? So security defaults will be enabled, but once you want to use conditional access policies, security defaults will be disabled. So in most organizations, when they actually start using conditional access policies and they don't really know what they're doing, or they're making a lot of policies with a lot of gaps in that, they'll probably be a lot less secured than if they were just using security defaults. Right. And then after that, we have a couple of slides, probably 10 slides, going over all the learning objectives, showing specific mitigations and detection opportunities for every single learning objective, right? So we will not go into too much detail of each of them, right? Because we try to cover as much of the defenses and detection opportunities already during the course itself. The things that we didn't really show in too much detail were how you could detect the attacks with the activity logs and things like that. But that is mostly the same for the most type of activities, right? In a lot of cases, abusing read access. So if you read things from storage accounts or read configurations, things like that, will not show up that much inside of access logs, right? Things that are most prone to being detected are when you actually start interacting with resources where you actually modify stuff, right? If you add secrets, client secrets to an application, very, very visible in activity logs, right? You can create custom detection rules for that, right? All right. Thank you very much, KSC. All right. So are there any specific questions about any of the detection opportunities for any of the learning objectives? Then we can go into a little bit more detail on that. Otherwise, you can always ask me later on, right? Maybe what we can do as one use case is I will show you an example of the consent phishing, right? For those that still have the time to join me for that. Otherwise, it will obviously be recorded as well, right? So let's close that again. Let's sign into the Azure portal again. So let's look at an example of how we could create some detection rules for the consent phishing, for example, right? All corporation, yes, that one. So for the defenders, this will probably be very useful. Most of you might maybe already know of that. So as I said during the when I explained the consent phishing, there are a couple of things you can look at, right? So if you go to enterprise applications, activity logs. So one obvious thing you see already over here, there will be a service principal for all of the applications where consent phishing was used for, right? So as I said previously, every time you want to have an if a user wants to sign into an application with their Enter ID credentials, it will always create an enterprise application, right? So this is already an indicator, but you can also see that in the logs as well. If I go to activity and the audit logs, so we are in the preview view. Let's go to the legacy view because the preview one sucks a little bit. We can see as much information as we can see over here, right? Okay, so let's zoom out a little bit or do that. Okay, so a couple of things that you could see in a consent phishing attack in your audit logs for enterprise applications, right? Something we covered today. You will see over here, there are quite a lot of logs after each other, right? So there is one primary one that is generated first at service principal, right? So students 6 created or a service principal called student 6 was created by the user RayKQ. That is a user that we targeted during the consent phishing attack, right? You will see if we open that, which information we have in there. So they appear as a user, the user that signed in. This is the service principal that was created. And you will see a little bit of information that you could look into, right? So here you will already see the redirect URI. So be careful of that. If you do a consent phishing attack, this will show up in your in the audit logs of the defenders. So they will be able to see this, and then they might start investigating your URI, right? So important to know as an attacker, important to know as a defender as well, to know where you can spot that, right? So a new service principal is created. However, that doesn't really tell us that much just yet. We will also have one at delegated permissions grant. So obviously, during the consent phishing, the user will provide some delegated permissions, right? That's what the consent phishing is about. We want the user to provide some permissions to our application, right? So some delegated permissions, right? So you'll see that the user has provided some kind of access to the application, right? So the service principal, if you would resolve that, this would be the student 6 one. And we will see that it is giving some permissions over the Microsoft Graph API, right? So some API permissions, right? Which permissions? We can look a little bit further in the modified properties. And here we will see the scope. So we will see that chat.read, user.read, and user.read basic all will be in there. These were the permissions that the application requested, and we will see that the user has given them as well, right, over the Graph API, right? Yes. All right. So what else do we see? A consent to application log. So this one is obviously very, very clear based on the name. You will see a little bit of the same information as the last one, right? So this user provided some consent to this application, student 6, the malicious application, and you will also see the scopes in here as well. So that is everything you will be able to see over there. So this provides you opportunities. If you ingest that in some SIEM or in Sentinel, you will be able to create detection rules on that as well, right? To have an analyst look into that if you see some kind of suspicious consents being provided for a new service principal, right? To provide you with an example. You will see whether it is admin consent as well. So here you can see that is admin consent true, right? Because the user that we targeted was able to provide the admin consent for the chat.read as well, right? It's not app only and not on behalf of all, meaning that it's not tenant-wide, right? It's only delegated permissions in the context of the user. All right. Any questions for me about this? So a question is, if we do not have a SIEM, will Defender detect those kind of attacks? So Defender for Cloud is enabled in here as well. But you will see if we go to the security alerts that even though we were very, very nosy, we did quite a lot of attacks in this tenant, right? This is the main tenant, and you will see there is no real alerts regarding anything that we did, right? There are a couple of reasons for that. First, it checks for basic normal usage in your tenant, right? And it creates a baseline of that on that, and then it sees if anything abnormally happens and goes outside of that normal behavior, right? So because this is a lab tenant, there will not be that much of normal behavior. So it could be partly related to that, but also just because it's not that good at detecting all of the attacks that we do over here. We see Azure Hound is being run a couple of times. This is something that we indeed have done. So if you don't know that, Azure Hound, you can also access Azure Hound from the lab. If I go to this URL, you will be able to access Azure Hound and to look into that a little bit as well. If you want to play with that, it is available. We didn't really use it during the lab because you will see that it will not find everything, right? It is nice to have an overview, right? But it will definitely not see most of the attacks, right? But it can detect a couple of things, right? So you will see there are some custom searches in there. For instance, find all the service principals with an enter ID role. If you execute that, you would see that it would find some stuff. And here, for instance, it would see Geology app as the help desk administrator role and the authentication administrator role, right? And the directory reader. So this is something that we abused, right? We reset the password of a user with help desk administrator. We created a tab with this. And we also see that it owns service principal, right? The XP storage app service principal, right? So it was able to create as a secret to that as well. All right, thanks for sharing that, Mimi Dogs. Okay. So with that out of the way, if there are no more questions right now, then we will round off this session, right? So please provide any feedback, you can send it in Discord directly to me or to the lab support team as well, or to Nikhil directly, right, about this course. You can follow me on Twitter as well if you want, with my handle over there. On LinkedIn, I am mostly active over there. And if you like this lab, definitely check out our other labs as well, and our other boot camps as well, right? So for any questions about the lab itself during the following days, you can reach out to the support team. But as I said, they will also be available in Discord. Yeah, other students might also be able to help and learn from you guys as well. So I would encourage you to use the Discord as well. Also, join our other security Discord. You will get the CARTE enrolled. Will be able to access the ARTE enrolled channel, right? So there you will be able to communicate and talk with all other people that have ever done this course, right? And there's some questions over there as well, right? Awesome. So I have a comment from Andrew. Thank you very much. This was a great training, very interesting. I learned a lot. That means a lot for me. Thank you. Thank you, Mimi Talks. Thank you, guys. So yeah, good luck on the exam, everyone. So do note the exam is a lot harder than the basic exam of the basic Azure course, right? So make sure that you understand everything from in the course, right? If you are able to do the labs individually, right, I recommend going through them through the lab manual manually, with the notes, and then afterwards try solving the lab without going through the lab manual. If you are able to do that, then you should mostly be fine for the exam. However, do note that the exam, it will not be 100% the same scenarios that you have encountered in the labs. So make sure that you are able to do some research on your own. If you encounter something new, that's you will have covered most of everything already. But obviously, we don't want to just copy paste the same stuff from the lab to the exam. It will be a little bit more challenging, and you will see some variations, right? So expect to be able to adapt to those situations as well. All right. Thank you, guys. Awesome. So with that, I think we can end this session. Thank you very much, and I will see you somewhere else on Discord probably, right? Bye.